and welcome to Eat3D's UnrealScript and Introduction and Application video training. We're going to start with an approach to UnrealScript from the perspective of being new to programming, but still moving at a brisk pace, allowing us to cover examples of different applications. We'll begin by walking you through setting up one of Epic's recommended UnrealScript IDEs for your development environment, Infringe, which is free for personal use. This will provide a good foundation for learning the UnrealScript language, as well as speed up your development with features like IntelliSense and UnrealScript debugging. After we're up and running, we'll go over the UnrealScript basics such as supported variable types, functions, class structure, supported flow control options such as conditional statements and loops, and extending and creating your own custom classes. We'll also talk about how to add your own Kismet functionality, which is great if you're working on a mod or game project and are looking for some project-specific access from the high-level Kismet game scripting. All the existing UDK UnrealScript files are available to browse and learn from and extend, but it's critical to have a good foundation and understanding of the language to help you take advantage of the powerful things you can do through UnrealScript without writing any C++ code. Finally, we'll spend some time creating a custom weapon and projectile class with a focus on creating a unique projectile behavior. You'll see how with an understanding of how class extension works, you can create very different and unique results with a small amount of new code to write, leaving you more time to design and develop your ideas. Just quickly, we're going to go over the UDK Unreal Development Kit interface here. As you see, I already have it open. You can download the UDK if you don't already have it from the Epic website. It's the full Unreal Engine 3 tool set that they provide free to download. You know, it's a great opportunity and tool for you to get in there and experiment and try some of your ideas out, whether it's prototyping something out or creating a mod, as well as you get a feel for the full kind of development environment that major game studios are using pretty much across the board. Many of the top games that are coming out are coming out on an Unreal Engine, as most of you are probably familiar with, and this is virtually the same, if not the same, tool set that those companies are developing those games with. So it's a really great opportunity. All right, so what we're going to do, though, is be spending most of our time in Visual Studio because we're going to be covering UnrealScript, which is the scripting system, or I guess you could say high-level programming language that Unreal Engine provides. Unreal Engine has the base level, game code and editor code, and then they have UnrealScript, which kind of sits on top of that. And then on top of that is the Unreal Kismet, which is kind of the game scripting or really high-level scripting that happens. And that is something we've covered in another DVD, the intro to Kismet. And so now we're digging a little bit deeper and going into UnrealScript, which is a lot more like coding or programming in C++, but it has some differences and some major differences, especially when it comes to compiling and being able to iterate on the stuff that you're working on and new stuff that you're creating. So we're going to be going over how to set up a project in Visual Studio to start to make some changes. We're going to cover the basics as far as the different variable types and kind of syntax of UnrealScript, as well as how to define your own functions, classes, and all of the good stuff that you're wanting to know. So let's go ahead and get into that now. One of the tools that we're going to introduce you to help out in your work with UnrealScript is the Infringe IDE by a company called Pixelmind. This works in Visual Studio, and it provides you both a high-level text editor for UnrealScript that gives you syntax highlighting as well as IntelliSense features to help out with auto-completion, and also a source-level script debugger for UnrealScript, which is very helpful if you're working on a large project or really kind of getting into the low-level stuff. If you're working through something complex, then script debugging is very helpful in the Unreal environment. We're not really going to be doing too much of that for the purposes of this video, but I still wanted to show you the tool, how to get it set up, and we'll go ahead and work in that environment throughout the video. So you can jump on over. This is the Pixelmind page. You can get all of the information you need about installing it from the wiki page that they have, which is this page here. It's going to give you an overview installation. We're not going to cover all of the installation stuff as they've got plenty of good documentation here to get you started. So what we're going to do is going to go ahead and jump into Visual Studio now with Pixelmind's Infringe already installed, and then we'll show you how to set up your project using the Infringe tool. Okay, so here we are in Visual Studio now. We've already installed the Infringe IDE from Pixelmind. So now we're going to set up our UnrealScript project. If you go to File, New Project, you'll see that the project type defaults to UnrealScript, which is what we want. We're going to use the Unreal Engine 3 licensee project template. Go ahead and name the project. You see we already have the location set to our UDK installation, which is the July version in this case, and the development and then source folder. It's really important that you set it up in this folder as a reference point. So if you're not already defaulted to that location, just browse to it here. Make sure that Create Directory for Solution is unchecked for this, and go ahead and hit OK. Alright, so now we've got a basic solution set up for us, along with the reference source, which is provided automatically, which gives you the information for your IntelliSense and syntax highlighting. So right now this is just an empty solution though, and we need some extra information here. You can build off of this if you want to, but what we're going to do is actually close the solution down, move the solution file so that we pick up all of the existing UnrealScript files in the installation of the UDK. So what we're going to go ahead and do is close the solution. We're going to browse to the folder that we created the solution in Windows Explorer. So we're in Development Source here. You'll see that it's created an UnrealScript project for Eat3D. So I'm going to go in there. I'm going to grab these files and cut them. You'll notice that the .sco file is a hidden file. I've got my properties set to show hidden files. You may not. So you might want to unhide that, or it shouldn't be critical to grab that. So we're going to go ahead and cut these and go up one level back to the development source folder. And we're going to paste them in here. Alright, so now we're back over in Visual Studio. We're going to open the project solution that we created. We're going to go into the source folder. And there we go. So now you can see the solution is here, and it's outside or at the same level in Windows Explorer as the folder. So now if we open that solution, so now we're in a lot better shape. You can see over here we still have our Eat3D UnrealScript solution with the reference source folder. But now we've got a tree structure of all of the existing UnrealScript files that exist with the UDK installation. So this is going to be really good for both reference and for building off of. So now we're going to go ahead and set up a few of the properties on the solution and the project to make sure that everything compiles correctly when you start adding new script functions or new script files. Okay, the next thing we want to do is we want to set up a couple of things in the properties of the solution that we've created. So we're going to right click on the solution, select Properties. Under the General tab, we want to leave the target game as Unreal Engine 3 licensee. And for the UCC path, we're going to set that to, you'll see we're in the UDK installation folder. We're going to select Binaries, Win32, and go ahead and grab the UDK exe. And then we're going to save that. And you also see under the Debug tab, we're going to set the Start Game executable to the same thing. So it's already remembered the directory we're in. So we're in UDK, Binaries, Win32, and select the UDK exe. And it's not a requirement, but it's helpful to set a couple of flags here. One is Disable Startup Movies, and also Force Windowed Mode, just for debugging. That way you don't have the game taken over into full screen, which is hard when you're bouncing out of that to actually do the debugging. If you hit a breakpoint or something, switching from full screen to back to windowed mode is sometimes very slow on video cards. It can also cause crashes sometimes, so this is just the best way to go. Alright, so we're going to save that again with those settings and close the project properties. Okay, now that we're all set up with our solution for our project that we're going to be working in, we're going to go ahead and kind of go over the basics of the UnrealScript language. We're going to talk about classes and how you can extend classes and use inheritance for that. Some of the terms we're going to be using may be unfamiliar to you if you're not used to object-oriented programming. So we'll try to cover all of that stuff and make sure that we explain the terms. If you are familiar with it, then you'll be able to move along pretty quickly and understand what's going on. So we're going to be talking about classes and extending classes. And then we're also going to just go over the basic variables available in UnrealScript, They're very similar to programming language such as C++ or Java. And then we're going to go over a little bit more of the specific breakdown of an UnrealScript file, such as the default properties of the file, which are stored in the same UC file class itself, as well as how you can define your own internal functions and override functions if you are extending from a base class. So that's a lot of terms right there. If you're not used to programming, just kind of hang with us and we'll get through this. So what we're going to do first is set up a example file. So I'm going to right click on the solution and say add new item. Normally you would be putting these new items probably in a subfolder for organization, but for the purposes of this video, we're just going to go ahead and kind of put it here at the top. And you can see, because we have Infringe installed in Visual Studio here, we come with a good array of different template files that you can kind of generate here. These are common things that you'll be doing when you're working in UnrealScript on a project. You'll notice there's the 3 different Kismet default files or templates, and those are for extending functionality basically to the Kismet scripting, which is their high-level scripting that is available in the editor. So if you have a new piece of functionality that you write in UnrealScript, maybe you add a new weapon or you create a new enemy type or AI type, then what you can do is add these custom Kismet files that will expose that functionality or whatever functionality you define to be exposed to the Kismet side of things, which can be manipulated from the editor side and done all through the level scripting. But for right now, since we're going to be talking about kind of the class structure and the different variables and some of the basics of just working in UnrealScript, we're just going to use a regular UnrealScript file here. And we'll just call this overview. Okay, so here we have just a basic file that is created from the UnrealScript template, and it literally has the bare bones. It is a class declaration, which you can see right here using the class keyword. And we've called our class overview since that's what we titled our file over here. And by default, it extends, which is also the term UnrealScript uses for inheritance. So if you're used to, again, C-style programming, then this would be inherits from concept. And we're inheriting from the base class in UnrealScript called object. Unreal Engine has, or UnrealScript has, a few kind of base objects, and one of them is actor. And that's going to be for anything that is going to basically show up in your world. Characters are derived from actor, even static meshes are derived from actor. Everything just about that you would place in a level and sort of interact within the game at its core is an actor to the Unreal Engine. Object is something more kind of abstract than that. This is going to be your general object that has like your base properties such as a location, rotation, all that stuff. So all that stuff comes from the object base class, and you automatically get that when you extend from it, and then you can add your own custom things to it. We'll go over the inheritance stuff a lot more here in a little bit, but I just wanted to kind of cover the default template here, just so you know. You also see this declaration for default properties. This is an UnrealScript kind of standard thing that the default properties are at the bottom of each file, and that's just saying any variables or internal members to this class that you set up here, somewhere in this range of the file, then in the default properties, you can go ahead and initialize those to any values if you want a starting value for those variables, and then that will be set up whenever an instance of that object is created in the editor, for instance. Then you would have some variables already come with a default. An example of that would be, if you have something that has a Boolean value of true or false, and by default you want this to always be true, but you give the person in the editor or who's going to be using this object, they have the option to set it to false, but you want it to default to true. That would be in the default properties. All right, so before we go any further with class stuff and some of the more object-oriented elements, let's just talk about the basic variables available in UnrealScript. Okay, so what we just did there was put in a comment line. The comment is delineated by the 2 forward slashes here. Basically, after that, anything on this line will be considered a comment, which means that the script interpreter or compiler will move over top of that and not really do anything with it. It's just for readability and for communicating what you're doing in the file. If you've done any programming, you know how important commenting is. It's important no matter what you're doing, whether it's in Kismet at the high level or here in UnrealScript, which is, a little bit more in depth and definitely a little harder to follow. If you're new to a file, then comments are going to be critical for you to sort of be able to understand what the author was kind of setting up and what the original intention was. So we'll be using comments a lot. Okay, so let's go ahead and start talking about the variables available in UnrealScript. The first one, which is very basic and is, depending on what you're doing, you may not use that much, but we want to just make sure we cover everything here, is a byte. A byte is a single byte value ranging from 0 to 255. This is very similar to, or the same as, the char variable in C-style programming, which is used to represent a single character in a string. So a string, for instance, which could be an array of characters, is basically an array of bytes, and that's what this byte variable represents. So okay, the next one we're going to talk about is the int, just int. Now, int stands for integer, which is basically a number with a non-decimal or non-floating point value. So this is 1, 2, 3, 4, 5, and so on, but not 1.5. If you want the decimal value, then you have to use a floating point value, which is a separate variable that we'll cover in a second. So integers are very useful for just your basic math. But for something like as complex as a position in the world, because you want to have that precision of being able to move something, in the case of Unreal, an integer value would force you to move everything in 1 unit in the editor terms, which, depending on your configuration, may be 1 meter, which is a lot, a pretty big step. So that's when you would use a floating point value to be able to move kind of, at any range of value between 0 and 1, for instance, in the case of moving an object up to a meter. But an integer would basically force you to the non-floating point value. So this is going to be useful for a lot of things. You'll use integers a lot in code, in UnrealScript, for instance, but you want to just keep in mind what your use of your variable is and kind of think of that ahead of time to make sure that you know what operations you're going to be doing on the variable, whether it's any math. And if you are going to be doing math on it, basically know that if you're using an integer value, it's going to be rounded to the nearest, whole number whenever you do an operation on it. So you could lose some precision or even have some what may appear to be subtle math errors if you're expecting the floating point value. The other thing about integers is that they are 32-bit, whereas a byte is 8 bits. So essentially, an integer is the equivalent of 4 bytes, which is relevant for the number of value that can actually be stored. Like, for instance, the byte up here can only store a range from 0 to 255 because of it being an 8-bit value. Now, with a 32-bit value, in the case of the integer, you have a much wider range or a much larger range coming in around 2 billion instead of 255, so quite a bit of difference there. And you don't really need to know, unless you're doing low-level programming, the specifics of what an integer can store. But just know that a byte is very limited in what it can be used for, and an integer can hold a lot more. You should use int when possible and save byte for advanced things like writing to a file or network replication type usage case. But you also, again, want to plan ahead as far as know what you're using your variables for. And if, for instance, you need this value just to basically represent a state, and you have a fixed number of states for, your object or your actor, then an integer is overkill because you don't need 400,000 states. You probably only need 10. So you can use a byte for that and easily just range your values from 1 to 10. Okay, the next thing we're going to talk about is the bool. The bool value under the hood is actually 32-bit. But what the bool is used for is just to represent true and false. So in code, you're going to see bools used a lot for kind of tracking conditionals, such as if statements. If this particular state or this value is true, then I want to do something. So in your functions or your logic that you're writing, you can use the bools to sort of track any changes to an object. Am I taking damage? That could be a bool. So you could have a condition in a function that's processing, every game tick that says, if I'm taking damage, do this, play an audio effect or play a particle effect or something like that. That's a very basic example, but just kind of trying to explain what you would be tracking these for. That's along those lines. Okay, so we already talked a little bit about this, but next is the float. So a float is also a 32-bit value, like the integer, but as we were saying, the float value can store the decimal value of a number. So you have a lot more precision with that, and so that's going to be a lot more useful, for things like position, like we talked about earlier, or rotation. Basically anything that you need kind of a high precision number for, and that's going to be a float value. And next we're going to talk about string. A string is what we use to represent basically a word or a sentence. It breaks down to a byte is a character. So if you have, the letter A can be stored in a single byte. So if you wanted to have the word apple and you display that as a comment or, output to the screen, you would need a string to store the word apple. And that string would be an array or a list of these byte values, each containing its own letter. Strings are a pretty in-depth subject, and there's extra stuff we can talk about on the strings a little bit later. They have different operations that you can do on strings, because what you're going to be doing a lot in script is going to be taking strings and concatenating them together, to be able to put messages out to the screen, whether also logging errors. If you're trying to kind of troubleshoot things, you can use errors, and they have special functions built in to operate on strings that will allow you to put together a sentence out of multiple strings and all this stuff. It'll make more sense when we get to it. So there are other variable types along with other keywords, but those are sort of the basic 5 that you'll be using for common operations in script. As you're working and working through extending other classes, you'll see other uses of them that will probably be kind of self-explanatory, or you can go do a bit more research on the Unreal Developer Network site. There's plenty of information, books available, but we just don't want to cover too many of the nitty-gritty details of what you can do, because we just want to kind of cover the basics and be able to get you going with writing your own UnrealScript files. Okay, so now we've already gone over a couple of the basic variable types. Definitely the most commonly used ones in the script functions you'll be writing or classes. So let's quickly go over also variable declaration. So now we know the types of variables. How do you actually declare them in script? So right here, we're going to go ahead and say var or var for a variable. And so this defines that you are declaring a variable. Here you have an option to put in a keyword. Some examples of keywords are const for a constant value. Basically, you're saying this value will not change or cannot change. There's also a couple other things, like you can declare a private variable. And what a private variable does is, in the case of class extensions or inheritance, which we'll be talking about later, a class that is derived from the class we're defining now would not be able to make edits to a private variable because it doesn't have permission. If you want to change that variable, you would have to expose the ability to change that through a function in this class, thus giving access to it in child classes. But we'll go over the inheritance thing and how to extend a class a little bit later. So just know that this can be a keyword value, but it's not required, and probably in most cases, you won't actually need to define a keyword. So the next thing that is required is the type. So this is, as we went over the variable types above, here's where we're going to define what type of variable we're creating. So we can say this is a bool. So now we've defined a variable that is going to be a bool, and now we need to give it a name. So we can just call it my bool. So you'll notice the semicolon at the end of the line there. Basic syntax for UnrealScript, and this is familiar to C programmers will know this. A semicolon is how you end a line, essentially. So when the script is compiled, then it'll go line by line, and every time it hits a semicolon, the compiler knows that that statement is essentially done, and it will do its thing with that, and then it will go on to the next line. There are some exceptions to that rule, but that's generally going to be something that you're always going to be placing at the end of each line. And again, if you've done any C programming, you know where that comes from. All right, so right there we have defined a bool value. It's not doing anything yet, but now, further down the line, we can manipulate that bool, set it to true or false. As we talked about earlier, that's a true or false value. But we could check against that by saying if my bool equals true, then go ahead and do this or call this function. A couple other things that you can do with variable declaration. One thing that you may be doing is you're needing to make changes to the object that you're creating an UnrealScript file for. Maybe you're going to make this a placeable object in the editor. For instance, you've got lots of different types of triggers. in the Unreal editor. You've got the default trigger, you've got different volumes which you can create from the brushes, such as a physics volume. Also, you can basically create your own and say, I've got this trigger type. You've got a game where you need a special type of trigger, so this is going to be your trigger 2.0 basically, and you want to have some special things that happen with it. Well, what you can do is when you're creating this class, which will be your new trigger, you can define variables when you're creating these new variables, and you can say whether or not you want to be able to edit these in the editor. So, just to back up, the option is if you want to have the object that you're creating in UnrealScript to be a placeable object in the editor, and you want to have properties that you can edit, then in addition to the variable definition, you can also put just simple open close parens. And what that does is that defines that this value should also be represented in the object's properties in the editor. Now, if you leave them blank, it will assume no category and just go to the default category. You have the option to type in, a category here, which could be my options, we'll say. So what that would do was when you placed an instance of this actor or object in the editor and you opened up the properties panel, you would see that there would be an additional category called my options with the my bool represented there, and you could set that value of that variable in the editor. So again, if you leave this blank, it'll just go into the default options category. If you do not put the parentheses on the variable declaration, then this variable will only be, I guess you could say, visible to the script file. You won't see this anywhere in the editor. All right, so moving right along. The other thing you can do with variable declaration is create an array. And if you're not familiar with the term array from programming, this is basically a list is another way to think of it. If you think of just a list of a lot of different elements. Now, an array is a contiguous block in memory. And so what you're going to get is you're going to get these different elements. So I guess one way to show it is if I say put the brackets here, and we'll just say 2, just to be simple. So what I've defined here is instead of just defining a bool called my bool, I've defined an array of bools. And my bool is still the name of that, but now I have 2 different components or items in the array. So you can get to that by when you're working with your bool, you can say my bool sub 0. And what that's saying is it's 0 base and saying I want the first entry in my array of bools. So this could be a value. And we'll say it's equal to true. Okay, so we've got true, and then you say my bool is equal, sub 1, is equal to false. So now you've got this array of bools, and the different elements in there each have a different value. So instead of it just being a true or false value, you've got this array, and now you have to, what they call, index into the array using that numerical entry, which is 0 based. So my bool sub 0 is saying the first element in the array is equal to true. My bool sub 1 is equal to false. Using bools is kind of a funny example for an array because you probably wouldn't do that too often, but it's a good kind of case for showing it. A case where you would see this more often would be something like inventory, for instance. If you've got weapon inventory, each weapon that you have, that you're carrying, your character is carrying with you, could be an element in that array. So, inventory sub 0 is the pistol, inventory sub 1 is the machine gun, inventory sub 2 would be your sniper rifle. For other things, you might be using dynamic arrays too, which mean that they're not necessarily going to be, the same length. Like we're defining this one as 2 elements, but it would actually be something that could change over time. And there's additional functions that you can use to say, like, I want to add a new element, and then the script intelligently handles basically allocating additional memory if it needs to change the size of the array. You don't have to worry about that stuff. That's getting a little bit more advanced though, so let's just go back to the variable declaration right now. Then we'll get rid of the array. So now we're back to just a basic bool. So the other thing that you can do is declare, there's basically 2 ways you can use a variable in UnrealScript. One of them has more or less, I guess you could say global scope, although global really isn't the right word, but to the instance of this class, the way we've declared this myBool variable is it is available to anything in the class. So its lifetime is the lifetime of this object. But you can also define variables that you do not want to stay around using the local keyword. So by defining the variable or declaring the variable with the local keyword instead of the keyword, var, we're going to have a value here, and we'll just call this some value. So what we have here is an integer that is has local scope to the function that is created within. And what that means is that when that function is complete and exits or returns to the calling function, that the memory that was allocated for this variable will be released back to the system, and UnrealScript has garbage collection that will recover that memory for you. If you're used to more C-style programming, you may be used to kind of allocating your memory as well as deleting the variables that you created. But in this case, you don't really have to mess with that as long as that's what the local keyword is for. So just kind of recap, the var declaration for variable is giving that variable, or is used for class declaration, and gives that instance of that object, that class object, this variable will have the same lifetime as that. And then inside of a function, when you're declaring new variables, you want to use the local keyword, which is what's telling UnrealScript that is local to that function, and when the function returns out, that variable no longer needs to hang around. In some cases, if you're doing like lower level C programming and you're used to allocating memory yourself, you also have the responsibility to clean that memory up. This just handles it for you. All you have to do is mark it as a local variable. So we'll do some more local variables when we get into functions later. So before we move on, I wanted to just quickly kind of add in a few more lines, more or less just restating what we talked about with the different ways you can declare a variable that you want to be available in the Unreal editor in the property panel for that object if you want to be able to edit this value. Just going to make sure that this is here for reference. So again, just the adding the parentheses will cause this value to show up in the property panel for this actor type. And then also you can specify a category by putting a named string, or just a string in general, inside of those parentheses. As we talked about too, there's the different keywords that you can insert here, such as const is one we talked about. I didn't really want to try to cover all of them, or even the more commonly used ones, because there really is a large number of these, and they all have a fairly specific use case. And you'll probably just pick up on a lot of it from when you're looking at other files and seeing how they were written and their use case. A lot of times too, it's sort of like if you're really writing like final game code, then there's a lot of things you have to consider, such as memory management and just safety, as far as like if this object is going to be if this class is going to be extended, you want to make sure you're using private or protected variables when that's appropriate. But in a lot of cases, just for kind of learning how the flow of UnrealScript goes, that's not necessarily going to be required, in my opinion. So it's not really something I feel like we need to cover right now. We're just going to kind of keep it basic and just kind of get you familiar with how stuff is structured and declared in this case, and then you'll pick up on a lot of the other use cases for the keywords as you're getting more and more familiar with UnrealScript. Okay, so quickly before we go on to kind of the other topics, we've talked about here variables that would be declared, inside of a class. We mentioned the local definition for inside a function. So as we're going through this overview, kind of in this overview file, we're going to be just kind of presenting everything in the simplest form, but just wanted to reiterate that outside of variable declaration and function declaration, pretty much everything you're going to be doing inside of UnrealScript is going to be happening inside a function. So even if we're showing, an example here, just kind of outright and plain, for instance, like a for loop or a while loop or an if statement, those are all going to be contained inside of functions at that point. And we're going to talk about functions in a little bit more detail later. But the basic kind of format is going to be function, my function, and at simplest format, that's a function right there. And so all the stuff that would happen, whether it was a local variable declaration or an if statement, which we're going to get to here, just all these different things are going to be happening inside of a function. So it's good to obviously understand this flow, and as you look at existing UnrealScript classes, you're going to see this pretty much, anything you're going to be doing operation wise is going to be happening inside of a function. General class structure is going to be a variable declaration, and then a list of the functions that are available inside that class, and then all of the logic for those functions is going to take place inside these curly braces. So just wanted to kind of reiterate that function is where you're doing most of your work. So as we're going through examples and showing everything kind of in its simple standalone format, just know that would be, when you're writing that stuff, you're going to be doing that inside of functions. Okay, so now we can go ahead and go on to the next sections, and we will come back to the actual topic of functions and talk about some of the other keywords and defining your own arguments and things like that in a little more depth. I want to go over just the basics first. So in addition to the different variable types, or at least the basic variable types that we've talked about in UnrealScript, I also wanted to cover arrays. If you're not familiar with programming or the term array, it's basically a contiguous list of variables that are stored in memory that way, and so they're all in order. And so what that allows you to do is to refer to them by one name, and then you can index into the different elements or indexes in the list. And so it's a really useful concept and used very heavily in programming, and so I wanted to make sure we covered that, but I wanted to cover it sort of after the variable types, because an array can be of any variable type. It's more of like a data structure or just a way to store that set of variables. So let's go ahead and put in our heading and show you how to define an array. Okay, so you're going to start out with the same variable keyword. Everything looks the same there, and for this case we're going to do an array of integers. So again, nothing different here than if we were just going to define the integer right here. But where it is different is if we're defining an array, you can add the square braces and then a numeric value inside of that. And so what you have here is, actually we're not going to set this equal to anything. You defined an array that has 20 elements in it. So if you think about this as a list, then you have 20 integers, in consecutive order, all stored kind of by this one name, and then you can index into them using the same syntax but using a single value, and this starts at 0. So you're defining it as 20 values in this array, or 20 elements, and then those index from 0 starting at 0. So what you're going to have is 0 through 19 are going to be your indexes or indices into that array. We can kind of chart this out. Maybe that'll help visually if we just do a bunch of the square braces. We're not going to go all the way. We'll just do something like this. But basically you have this from a standpoint of indexing into the different elements. Each set of square braces here refers to one integer value. Now, these numbers here are not the value that's being put into that integer. What this is syntax would be is if you add that to the myArray name, so you put the name of the variable and then you do say sub2, then what you're actually getting at now is the element at sub2, which is the third in the list. You have 0, 1, 2, and you can set this to a value, and that value could be well, just make it not confusing. We'll just make sure it's something well different from 2 is 5. So the value, or the integer value in element 3 or 2, it's the third element in the list, but the index value is 2, is now equal to 5. And you can treat this, this syntax right here gives you access to that variable, so you can do arithmetic on it. You can do whatever you would normally do with a variable. But you have this nice collection of them that are all in order, and because they're in consecutive order like this, this allows you to do things like use for loops, or a way that basically a for loop or a while loop, some sort of loop that you can walk the array if you want, starting at 0 and keep
checking each value. So a common thing you'll see is to do a for loop. The number of iterations is the number of elements in the array, and you start off, an index at 0, and so you've got that first, element or index into the array, and then you just keep incrementing that by 1 as you normally would in a for loop, but now you're basically walking up the array and, doing either an operation or checking the value of each element. And then at the end of the for loop, you've hit every element in that array, and so, based on whatever context you have, you can break out of the loop, or you'll at least have the information that you need. Okay, so I'm going to erase this right here. So that's pretty much it. I'm going to throw a comment on here, just to be clear. So, again, because you're using a keyword here, this could be any of the variable types you want. My array 2, and this could be 4 bools. So that's confusing naming right there. That should be like array of bools or something like that. But I just want have something to contrast here. That this is an array of 20 integers. This is an array of 4 Boolean values. So you could have an array represent your inventory, and you've got, maybe you want to have one that just checks to see whether or not you have the weapon. So if you have weapon slots 1 through 9, then you could define an array of 9 and then make it a list of bools if you wanted, or an array of bools. And then you could, as you acquire a weapon or pick up a weapon or grant them a weapon in script or in the game, then you can set that bool to true or false of whether or not they're carrying that. And then, just for simple logic checks where, say, you need to do something, but you need to know whether they have this particular gun. Like, say there's a script or a scripted scenario in the level where they need to use a particular weapon to remove some sort of blockage in the level to proceed. So they need to have the rocket launcher to blow up the wall that or the door that's blocked off, that's keeping them and gating them from where they need to go. Well, in the scripting logic, you might need to run a check and be like, hey, we need to make sure they have the rocket launcher. If not, we need to communicate to them and give them a message and be like, hey, you need to go pick up a rocket launcher. I mean, that's just a simple case, but that's where you might use an array of bools. There's other ways to do that. I mean, you could also just iterate over the array of actual weapons and check to see whether the weapon exists. It depends on what functions the classes that exist, have, or if you need to add something. But it's good to get to kind of the high concept of how this works, and then how you can, iterate over it using a for loop or a while loop and check each of the elements inside of the array. Okay, so it's kind of a lot on arrays, but if it's not something you're familiar with, it's sort of a different concept, so I want to make sure that I talked about it at least a little bit, and then as we're going into the future stuff with the classes and some actual examples in the editor and game, then we'll probably be at least referencing arrays, if not creating some new ones.
Okay, so let's go ahead and talk about some more variable types and classifying these as some more advanced variables. These are things that you can use to speed up the code process, make it more readable. So let's just go ahead and get started on that. The first thing we're going to talk about is the enumeration type. The keyword for that is just enum. So let's go ahead and give ourselves a heading here. All right, so we're going to start out with the enum declaration. And again, the keyword is enum. And we're just going to call this enum game developer. Okay, so what we have here is a basic declaration. We'll go ahead and add some curly braces here, which is going to contain the values. And we're defining a enumeration called game developer, which in this case is going to represent the different disciplines or the different roles that a game developer might have. Just a simple case to categorize something. So we'll start out with, could be an artist. So we're going to use GD underscore and put a comma there for the next entry. And you can either do this all on one line or drop it down. I like to drop them down for readability. Could be a designer. Could be a programmer. And we also could have an audio. Okay, so there's 4 kind of high-level disciplines. Of course, you get producers and all those other different roles, but we'll just keep it simple for this case and show these 4 different kind of disciplines or roles that a game developer might have. And so what you're actually doing with an enumeration is you're basically assigning a named value to a number representation, numerical representation. And the reason that this is really helpful is, for another example would be like a weapon type or ammo, is if you're going through code, whether it's you're revisiting code that you've written or somebody else is coming to look at your code for reference or maybe to fix a bug, using enumerations in cases where just a numerical value is assigning a very different classification to a variable, then this provides a very readable way. For instance, if you're assigning weapons to your inventory, if 0 represents pistol, 1 represents a rifle, 2 is a shotgun, and 3 is a sniper rifle. If you're assigning or adding to your inventory, the value of 2, then yes, that's getting exactly what you need, but that's not very readable. But if you had all of your different weapon types in an enumeration, then you could assign the name shotgun or some name like that. And what it's doing is just assigning that value. But in the case of looking at the code, it's very obvious just at a glance what it's trying to do. So let's go ahead and just really quickly go through a case where you could use something like the one we've defined here. So we're going to define a new variable, and it's going to be of type gameDeveloper, and we'll call it newDeveloper. Semicolon to end the line. So right now this is just going to be the default value, but we're going to go ahead and assign it right away to the value of the designer. So now we have this variable, which is of type gameDeveloper, which is our enumeration. The title of the variable is newDeveloper, and we've assigned it the value of designer, which is also equal to the value of 1. We'll go ahead and put this up here just to keep in mind that this is 0 based. So what we've essentially done here is assign the value of 1 to this variable, newDeveloper. But again, for readability purposes, designer is a lot more meaningful in the context of what you're trying to write code for than the value of 1. So if you have some function that's doing process, say in this context of a new hire, say you got a function that you want to run when this person starts that assigns out maybe their seat number or their workstation specifications based on discipline, whether you have a different setup, something like that. Sort of an abstract example, but something that kind of puts it in a real world context. So if you had a function that's like new hire, assign data or whatever, and inside that function you might have an if case. And so what you can do is now you can check that newDeveloper against a value. Say, is this an artist? And so if it is an artist, if that newDeveloper was set to, in this case we would be passing that into the function or whatever, but just kind of take this in a real simple context. You can check against the value of newDeveloper to see if it was equal to an artist. So what you're checking is this value equal to 0? It's not in this case because we assigned it to designer, which is equal to 1. So this would not test true. If we had another case here, an else if, and we're going to talk more about if statements here in just a few minutes. Keep the spaces inside here for just readability purposes. A lot of coding conventions for different companies will have it be one way or the other. They may prefer it to be kind of tighter to keep the lines shorter, or may prefer the more readable kind of format like that. So in this case, we had an else case here. So we're also saying if it's not that, what if it's this? And we're checking against designer, then we could call some other function. And it could just be that the actual processing is done inside this if case or whatever. Just an example, it could be some amount of script or code that you run here if this value is equal to this. So that's a really kind of simple use case of how you would use an enumeration. Starts at 0. You can define any named. It could be fruit. It could be weapons. It could be time of day. You could have a morning, day, night, or even middle of the night or midnight kind of setting. And maybe that's running different code for your lighting or your skybox or something like that. And so you can be checking in your update functions for the game to see what time of day it is, essentially, if you're kind of snapping to certain time periods. And that gives you just a really readable way to say, if daytime, set values to this, and if nighttime, set them to something else. So enumerations, just again, really good for readability in code and for kind of writing code faster, not having to spend a lot of time tracing back up to where, say, the weapon list, or in this case, the list of developer types was defined. You just kind of know by that name. All right, so next we're going to talk about structures. Okay, so we're going to talk about structures now. One way I like to think of them as like a very simple class. We haven't talked about classes yet, and we'll get to that, but this is kind of a very simple construct of a way to group some number of variables together into an object that can then be created or instantiated as a variable inside of a class. But structures cannot have functions in them. They're basically just some amount of data, and but that's all kind of grouped together into a nice package. So what we're going to go ahead and do is show you how to declare a structure. The keyword here is struct. You see our IntelliSense helps us out with that. So we'll call this element type rating. So say this is a game where you have using kind of the 4 classic elemental types for your powers. So you have spells or different weapons that are based on these powers. So here we're defining maybe a rating system or a point system that can be assigned to a character class. We'll say for the example we're going to do it's from 1 to 100. And this is basically their stats in that particular element. And so if they have a lower stat rating, then moves of that element type or powers or spells would be less powerful. So same kind of a curly brace definition here. And what we're going to do here is we're going to define 4 different variables inside of the structure. So we'll use the same variable keyword. We're going to define these as integers, so the int keyword. And we're going to define the first one as fire. And lastly, we're going to do the earth. Okay, so right there we've defined a structure. And we're saying element type rating has 4 different values inside of it. They're of the integer type. And we have given them a name of fire, air, water, and earth. So now what we have is this kind of nice little package to where we can create variables of this type. And these variables will be all kind of come with that as like sub-variables or part of that data object. And so it'll make more sense here if we go ahead and do an example of it. So we're going to define a new variable, and it is going to be of the type of structure we defined just above here. And we call that myStats. So now we have our variable of the type of structure. It's called myStats. So myStats now contains all 4 of these different variables, which have not been instantiated yet. So what we're going to go ahead and do is go ahead and give those a default value in the case of what we're doing here. So we have myStats. And to use or to access an element of a structure, you're going to use the period, which they call the dot operator in C++ style code. If you're used to C++, you'll know of pointers, which use the arrow operator, and then also the dot operator works, and they have slightly different use cases in C++, but in UnrealScript, it's just everything is on the dot operator. So just throw that out there. If you're used to C style coding, just know that you're always going to be using the dot operator here. Okay, so we've got myStats, and we want to access one of the elements inside of the structure, and we just do that by name. So myStats.fire is giving us access to the integer value up here, which is named fire. So here we can assign a value to it, and we'll say 50. So we're going to go ahead and do the next one, and we have the value or air, and we'll give it a rating of 25. Water, we're going to say, you know what, this guy has no water ability whatsoever, and it's not very good when it comes to the earth element type. Okay, so we have our variable that we've defined as a structure type, and now we've went ahead and set up the default kind of values. They're not really the default values, but we've instantiated values to that. So now we have valid data in each one of these 4 variables that we can access. So now an example of how you might use this and why structures are really good is because then you can pass the object around to functions as a single variable, because right now we have one variable, which is this myStats, but it has 4 different values in it. But say we had a function that was generatability. Instead of having to pass it 4 separate integer values, which would be one way to do it, and of course you need to give these a name, but instead of having to pass all that information, we can just say, you know what, just give it myStats. It's just a single variable, but yet it has all these parameters inside of it. And so now we're passing that to that function, and inside that function it can access the different elements or different variables in my stats using the dot operator like we did here. And that's going to give them, or make it a lot easier to kind of pass the data around, keeps this nice and clean instead of kind of blown out function calls where you're passing a lot of variables that you have to keep track of. So that's a really nice thing about structures. But the other cool thing is that you can still access just a single element of it. Say inside of generatability, it's running processing on all 4 of these different variables, trying to figure out maybe which ability it's going to use, or maybe the generatability basically picks your highest stat or rolls to see which ability to generate and bases the stats on the probability of it. So you might have another function inside of generatability, which is going to apply some damage value to the ability that's being created or being generated by the code. So in that case, all you really want is the fire variable, so you can actually pass just the fire portion of it as an integer to this function. Now that does assume that the declaration of this function is waiting on an integer, and in this case the declaration is waiting on the element type structure. But that's all in how you generate the functions. These are 2 simple examples of how you might call those functions. And of course we need our semicolons. So that's kind of a quick overview of the structure type. Again, it's similar to classes in that you can define any number of variables inside of it, and those are all contained inside of the object, and you can use the dot operator to access the individual variables. But the main difference is that the structure cannot have functions defined inside of it, and so it's basically meant to be a lot lighter weight, just a data container more than a functional kind of class type operation that you would use classes for.
And also with the defining the variables here or assigning them a value, this kind of, as we've been doing in the overview file, is just showing you a visual example. These variables do not have a global scope, so you cannot actually do assignment outside of a function or the default properties. So the setting up of the actual defaults here would happen down here inside the default properties. Or you could also set these inside of a function if you had a initialize stats function or something. That's where you would actually do the assignment. But this is just to kind of give you the reference to how you reference the different variables inside of the structure and kind of set up how we're going to be passing it around. But this would need to happen somewhere else.
Okay, so that kind of covers structures. And next we're going to talk about flow control statements. Yeah, let's go ahead and do that. Okay, so with flow control statements, we're going to cover 3 different kind of basic types. One is the if statement, which we'll do first. We're also going to go over the switch statement as well as loops. And there's a couple different types of loops we'll talk about. Okay, so with if statements, you can do just a basic if, which is a conditional check. If you've used visual scripting like Kismet, there's the compare actions. You can compare different variable types like a bool or an int or a float. That's basically an if statement, and it's in the action that it does there, and then you get to choose the condition from the options. Well, in the case of the if statement here, using the keyword if, you're just going to be defining the condition inside of the parentheses for the if. So for a simple case, if you had a bool variable, say my bool, then this in itself is a complete if statement. Because the value of the bool will determine whether or not it passes through and executes whatever is inside these braces. So since a bool can only have the value of true or false, then either if it's true, it will do something in here, and if it's false, it will skip over and begin executing at the next line after the if statement. You can also add conditional checks here using the comparison operators such as equals. So we could check to see if this bool is equal to true, which would be completely valid. If it's true, then it's true and it goes through. If it's false, then it's false and it goes through. But in the case of a bool variable or even an integer variable, what you're essentially evaluating here is a 0 value is equal to false and a non-zero value is equal to true. So if you had an integer value that was 1 through 100 anything, it would always consider that true if you were just checking for that int. So if you had my int and it was equal to any non-zero value, so right there, this would always execute it as long as this variable was not 0. You won't see, at least when in the bool case or in a non-bool case, you won't see this used very often because
that's not very intuitive or readable. You want to try to keep in mind that shorter lines of script or code is not always the best way to go, because readability is a big part of it. For instance, the enumerations that we went over earlier, that's all about kind of adding that readability to your code. So I wouldn't recommend using integers in this example. Bools are a little bit different because they can only have those two values, true or false. So that's kind of intuitive, especially if the variable is clearly named that it's a bool, or if you're using any sort of bool notation. Could be like b underscore something, and so that kind of tells you that it's a bool variable. Hungarian notation, which some people use, although in UnrealScript you may not see it used too often. So in this case, we'll just leave it as my bool. I just wanted to go over kind of the different examples. But then the conditional check is where you would get into, if it was going to be an integer, you could say my int is greater than some value, basically greater than 0, which is still that simple true or false. But where the comparison operators is really useful is when you start to add in the else case, and that's what we're going to talk about next. Is you have the if case, you can say if true do this, but then you have the opportunity to catch that in any number of else if statements following that. Actually, before we talk about the else if, let's just go with the else. And this is just a simple binary kind of operation of either or, saying if true, then do something else, do something else. And so this is guaranteed that one of these sections of script, whether it's the true case or the false case, is going to be executed because you just have the either or option. You can then insert, before the else has to go at the very end if you're going to have an else case. You don't have to have an else case too. You can just have an if, and if you don't care to do anything, if it resolves to false, then you just leave the else off and then the script just continues to execute. But if in this case you put in an else if, this allows you to do additional conditional checks, but it will only ever execute one of the if statements in a block of ifs and else ifs. So what I mean by that is if we had multiple else if cases, and there was something happening here, because these are else if statements, even if they would evaluate to true, they won't. This code inside of them will not execute if any previous if statement has also resolved to true. So let's set up a better case here for displaying that. So we've got this the my stats up here from our structure example. So we're going to say my stat dot fire. So for this case, say let's assume we're inside maybe of the apply fire damage function here that we were talking about. Like you've called some function that say I want to trigger an ability. I want to evaluate my stats and maybe use my most powerful stat, or I know that I want to use a fire ability, and so basically I would just want to generate the damage values or the particle effects, or maybe you have like a fire ability that has different stages based on your stat level. There's like the basic, the powerful move, and then like the super uber, I will destroy anything in one shot kind of move. And maybe that's only true if your fire stat is maxed out at 100. So if you just have a couple of simple cases, then what you can do is check here and say, if my stat is less than, my stat fire is less than, if this is less than 25, then we want to do something here. And so we'll say, small fireball. And then we're going to check another case. We're going to say if my stat, we'll say 50. We'll just kind of move up in easy incremental steps here. And we'll do our medium fireball. And then last case that we have here is 75. And this would be the large fireball. Okay, so what we have here is we've come in, so we're inside of the ability, generate ability or whatever the function is that's testing against the fire stat. We're saying like how big of a fireball are we going to create now that the player has initiated firing an ability. Okay, well, let's find out. So we're going to hit these if statements and check against the stats and say if their stat up here is less than, if this value is less than 25, they just get a small fireball. And maybe this also sets up some damage value based on the actual stat, like a modifier. So you're not getting consistent damage for all values less than 25. 0 to 25 would have increasing damage, but you might just say for the particle effect, we only care about like those large kind of incremental, like, hey, you've essentially leveled up and now you have a bigger fireball from a visual standpoint at least. So in this case, you could say, instead of saying they have to max out 100, you could just say if they're in that top, 25% of their available score, then anything above 75 and is toast. Like, you're just going to fire their Uber ability and it's going to destroy whatever it hits or whatever you want. You could also add another if case, else if that was just checking for if it was maxed out at 100. You can basically build as many as you want into here. And the most common case you're going to see is just the if and the else, so you won't see a lot of else ifs in there. There's other ways, such as switch statements, which we're going to talk about here in a second, to handle cases where you want to test against a lot of different ranges of a single variable. So a lot of times you're just going to see this, or even just the if statement by itself with no else. Like I said, you don't have to do processing on once you checked a condition with an if. You don't have to do anything. If it resolves to false and you just don't want to do anything, you don't have to put the else in there, and it will just continue to execute. That's a real quick example. Let me undo here and get this back, and we'll just leave that up, of how you can trigger or chain the else ifs. And then again, if as it comes in and starts evaluating, once it hits the first if case, if this is false, it'll look and see that it has another else if. If that's false, it'll keep going. But if this resolves true, then it would do the script or the code for medium fireball, and then it would skip down to the end of the chain of else's here, because it knows that it can only hit one of them. Okay, so that's a quick overview of the if statements and kind of flow control that you can do with that. One last thing that I'll mention here is that if conditions can have more than one condition check per if line or if statement. So if you want to do that, there's two kind of operations you will commonly use, and that is two of the ampersands means and then you also have the straight brace or pipe, which is or. And what that means, and or, are two binary operations that you can put into an if check. And so what I can do here is say, maybe I only want to do this line of code if my fire stat is that, but I also want to make sure that my, we'll say, water is greater than 0. Funny case here, don't know why you would do that. But you're saying, like, I need to know if I have fire less than 25, but I also want to make sure that I don't have 0 on my water stat, or maybe earth would be a better one for this case. So we have, this is saying that this must resolve to true and this must resolve to true. If you change that to be the pipes, then the or means that only one of them needs to be true. If they all are false, this will resolve to false. But if this is true or this is true, then this code will execute. And you can chain, multiples of these. You can have as many as you need to, although, keep in mind readability, and in some cases it might not make as much sense to overload a single if statement with a lot of different conditions. It might make more sense to nest them, which you can do. You can do a case where just basically would take whatever, condition you were adding up here, if it makes more sense, not saying it always would, but you can also just do this, and you can have a separate set of code that runs in here. So maybe if their earth stat is greater than 0, you want to add like a modifier to the ability. So you could set up something like that. So you can basically say, if my fire stat is less than 25, I know I'm going to fire the small fireball. But I also want to check to see whether, my earth stat has some value meaningful, and I want to apply, modifier or something like that. So you probably will see, a lot of cases like this if you're looking through existing UnrealScript and kind of whether it's reverse engineering or just extending classes that have functionality that you need, but you want to change it for your custom uses. We'll get into all of the class extension here pretty soon, but I just wanted to show, the nesting is fine. You can nest as many as you need, although again, just keep in mind readability of code. So that's another thing you can do. We'll leave that actually there, and then so next we're going to go ahead and talk about the switch statement, which is another flow control statement.
Okay, the next flow control statement we're going to talk about is what UnrealScript calls case statements. They're also known as switch statements in C++. So the case statement is a really good handler for when you have a variable that could be a certain kind of defined range of values. This is very much a use case for the enumeration types that we went over earlier, to where you have a enumerated set of values. Each value represents something different about that variable or how it would be processed. The switch or case statement allows you to very clearly kind of define what processing will happen based off of what value that variable currently has. And it's a little bit cleaner in the case, especially of using an enumeration, than using a set of if and else if statements. We went over that here, and this can be very useful for kind of comparing against arbitrary values or however you need to do that. But when you know exactly what you want to happen for a very specific value, then the case statement is a really good candidate for that. So let's go ahead and show you how to set one of those up. The first keyword you're going to use is the keyword switch. And then in parentheses, just like you were doing an if statement, you're going to define what variable that you want to do the case statement on. So if we go back up here to where we had defined our enumerated type of a game developer, and we declared a new developer, and we assigned it to the value of game designer, which is also the value of 1. So if we go ahead and kind of use this example here in our case statement, then what we're going to do here is put new developer here, which is our variable, and we're going to go ahead and do the curly braces. And inside the curly braces here, what you're going to do is you're going to define what set of processing you want to do for each potential value. And then you can always catch have a default case, which will just catch anything that you didn't specifically have a check for or a particular handling for. So the keyword here is case, which is where the case statement comes from. So here you're going to put in the value that you want to compare, or that you want to check to see if new developer is that value. So this could be, the value of 1, or 0, 2, whatever. But because we have that enumerated type, we can also go ahead and check against that. So we can say, is this new developer currently the value of an artist based on the enumerated type? And use a colon here to define the end of the case statement. And then here you're going to have any processing that you would want to do based off of the value being artist. So we'll just say do. Okay, and then we're going to put in the keyword break, and we'll explain why in just a second. So we'll go ahead and drop down to a new line here, and we'll make the second case, and this is if it was a designer. Add the colon, drop down, and then we're going to go ahead and break here as well. Okay, and then finally we're going to do the final case based on our enumeration. And I just remembered that we actually defined the fourth discipline type for a game developer, or for the common, and that was an audio designer, but we'll just call it audio. Okay. And then the very last thing we're going to do is go ahead and put in the keyword default with the colon. And we're going to and then we still want to break here, although this is not technically required because it's the last thing in the switch statement or case statement. So once it finished the processing here, it would exit out of the case statement just because there were no additional lines to process. So let's go ahead and back up to the top here and go over what each of these keywords is defining. So again, the case is basically the value that you are wanting to check to see whether the variable that was passed in is going to be currently set to. So we've got the value of new developer, which we know based on what we set it on up higher in the file is currently set to the value of designer, which is also the value of 1. So what this is saying is it would come in, it would evaluate, is the current variable set to artist? No, it's not. So it would pass over any functionality or any script that is in between these case statements. And so when it gets to the second case statement, it's going to test true for this, kind of like these are sort of like if statements, but like I said, it's a little bit easier and cleaner than stringing together a long chain of if and else if. This is a lot cleaner and a little bit more readable, just to kind of see the very specific values you're checking against. The if statements work well when you're checking against, sort of a range of saying like if this is between this number and some other number. But when you really just want to test on a specific value, this is kind of the cleaner way to do it. So currently, with the value being set to designer, it would go ahead and come in here and execute whatever script was between the case statement line and then the break statement. Now what the break statement is doing is it's going to cause it, in this case it skipped over all of this because it was not equal to artist. It would test true here, and so it comes in to do this. If you do not have the break statement, which is right here, then what it'll do is it'll actually begin to fall through the remaining case statements and continue processing them. It's already found a case that was true, and so essentially it's just going to start going through and executing all the remaining script lines unless you put a break in to stop it. So if whatever script we were going to be writing in here needed to be very specific and only done if it was an artist or designer or programmer or an audio guy, then you would want to make sure that you had a break statement inside of each case to make sure that it didn't fall through and apply any of the script processing that you had only kind of wanted to reserve for that particular discipline or a person in that discipline. Now, the one interesting thing about this is you can intentionally leave this out in certain cases to where maybe you actually do want two of the cases to do the same processing. If that's true, then what you can do is you could essentially just remove this, and you could still do some processing here if you wanted to. So let's leave that in there. Something specific. But by omitting the break statement here, if we come in, a new developer set to artist, it's going to do the scripting, or however many lines of scripting there are between the case statements, and then it's going to fall through and also do the processing inside of the designer case. Then it's going to hit this break statement, which is going to cause the execution to skip basically to the end of the curly braces and start moving down from there. So if the case where these two disciplines say whatever code you were assigning as far as setting up their profile or their seating assignments, whatever the case would be, then if say artists and designers have very similar kind of setups, then you don't really need to do anything specific, although you do have the option to say if it is an artist, do something specific. You could omit all of the scripting from this case and just basically stack two cases on top of each other. And you're saying if basically you're creating a case where you were doing an or in an if statement. So you're saying this or this, do something. And so you're saying if it's an artist or a designer, do that. But you still have this nice readable format, and then you can still do the special case processing if you wanted to for another discipline. So the default keyword down here, you always want to put this in at the end just to make sure that something gets handled. Even if whatever you're doing here is just logging a message saying, no processing was done, or maybe that is considered an invalid value for the property, like you are always expecting the value of the property that's passed in to have a matching case, then the default would be where you could log an error. So, but you can also have, if there's default processing that you always want to happen to everybody, that's where it gets a little tricky because you can only have it fall through until the next break. So unless you were to omit all of the break statements here and only have one for the default case, then technically, yes, it would fall through and always hit the default processing, but whichever one it triggered first would technically give it more processing. So if the value was audio, because it would skip these case statements and hit this one, then it would fall through default, but you would have missed whatever else you might have had up here for the other disciplines. So case statements are not great for when you basically want to, in that case where you wanted to do almost all the processing inside of default, you would really not want to put that scripting inside of the actual switch case. You would want to just handle the very specific things to these values, and then you'd want to have some additional scripting outside of the switch statement that went on to operate on the new developer variable, but handled that kind of, uniform scripting or processing that you want to do on that variable, independent of what the value was. So again, we'll just kind of review this really quickly. You've got the switch keyword is how you start it off. In parentheses, you're going to put the variable that you want to check each individual case line against. The case keyword is followed by the value that you want to check to see if this variable is. So this could just be a numerical value. In this case, we're using the enumerated list of values, which is what the new developer we know is based on. You remember that if you do not have the break keyword, it will fall through to the next case statement and do whatever processing and continue to do that until it does hit a break keyword. So you generally would always have a break inside of each case if you only want to do very specific things to the variable based on its current value. In this case, we'll leave it as an example that you can stack them like this and have them fall through. And then you have your default keyword, which is where you will just handle whatever would, if anything needs to happen, if the value that was passed in is not equal to any of the specific cases that you had called out. So another reason that it's good to put the default in is if you're thinking about your scripting, your programming in the sense of scalability, is if that enumeration ever changed as far as the number of entries in it, say they added an additional value to that list, then this case or the switch statement or case statement now has, unless somebody comes and updates it, a missing case for a value that is now valid for the new developer or the game developer variable type. So that's where default is good to have something in here, whether it's just a log or something that catches an error and just handles some sort of script case where you need to at the very least you need to tell whoever has made the updates that, hey, there's something wrong with this, or you need to come update this code too because the value of new developer changed. I mean, you could be that explicit with it of just having a log error that says if this log statement has been fired, then the game developer enumeration has been updated and the matching switch case or case statement has not been updated to reflect that. And that way you've got a really easy way to trace back and figure out what needs to actually be fixed. Okay, so that's the case statement, or switch statement as it's commonly referred to. And just realize that I've had this as state and not switch. So there we go. Case or switch statement is how it's commonly referred to. All right, the next thing we're going to talk about is more flow control statements, and this is going to be the one that you're going to be using a lot, just like the if statements, and that's going to be for loops and occasionally while loops. So we're just going to kind of categorize this as loops in general and talk about how to set those up. So there's basically two different types of loops, and those are for loops and while loops. So first we're going to go over the for loop. You'll see these used more commonly in your kind of average UnrealScript case. While loops are useful in certain cases where you're doing something kind of constant, or you have a potentially very long-running loop where you have another condition that's going to be checking into it, say like a bool or something like that. But for loops are very useful for when you have a fixed number of things that you need to loop over or iterate over, as you'll hear it referred to. So if you have a set number, in the case of an enumeration, there's a fixed number of entries in an enumeration, so you can loop over the length of that enumeration, so to speak, and be able to hit all the elements to check against them. So what we're going to do is set up a for loop right here, and we'll go ahead and put in our header. So you're going to start out with the keyword for, and we're going to do a space and do a open and close parentheses. So inside the parentheses, you're going to need three different values or elements to define how the for loop will run. The first is going to be what you'll hear referred to as the index of the for loop. So what we usually, the common convention is to use I for index. So you'll see I equals 0. It's very common to start out because a lot of things in coding UnrealScript or C++ are 0-based, such as arrays. Then you'll see that 0 will be the first item that you want to set I to, so that you catch the very first element in an array or whatever other type of structure you're going to be iterating over. Now, I say I is kind of the convention for the index of a for loop, and you will see it a lot in a lot of cases where you're looking through different code files or different script files. In this case, you will see I used a lot. But I would actually kind of encourage you
to name something more meaningful than I. If you're iterating over a list of items, then call it item ID. Something that kind of provides that readability, similar to why you would want to use enumerations throughout your script to kind of add that readability to it and provide a better context for what type of operation you're doing. For loops are a good chance to do the same thing by defining it as something named kind of appropriate to what you're iterating over. For this example, we're just going to leave it as I, but just know that you can name that anything you want, and it's a good opportunity to name it something meaningful given the context of what you're going to be iterating over in a for loop. So the second thing you're going to do is define what you're comparing against for the exit condition of the for loop. So the first element right here is defining what you're setting the start value of that index variable, which is going to be I. Second, you're going to say, I want a loop for as long as I is, in this case, we'll do less than 4. All right, so now we're saying start out with I at 0, and we want to keep running this for loop every time, continually until I is, or as long as I is less than 4. So you're kind of like an if check. You're testing for true. So you're saying, is I less than 4? If so, go ahead and continue looping. And then the third element that you'll be putting here is generally going to be what you use to increment your variable. So the syntax for that is I++. And you'll see this is another kind of borrowed convention from C programming. And this just increments the variable by 1. So in the case of this, you're setting I to 0. You're saying as long as I is less than 4, keep looping. And every time you make an iteration on this loop, increment I by 1. So in this case, this for loop would run 4 times because you're starting at 0. So I is 0 is less than 4. And then you increment it each time. So you're going to have 0, 1, 2, and 3. And then the 5th time through, when the I is equal to 4, this is going to resolve to false, and therefore it will exit out of the for loop. So if you put in kind of the curly braces here, now we can define some statement that we want to run. And a good example for how this is, there's a log function for UnrealScript. And we can just log a string here. So right there we've said the value of I is, and you can use, they have different string operators, and in this case we're going to use the $sign. And this is called concatenation. If you're not familiar with that term, you're saying I want to take 2 separate strings, in this case string number 1 here, and you want to merge it or append the second string onto it. That's what they call concatenation. So here we're going to put I, and this I'll figure out that it's a alphanumeric symbol, but it will append it on there. So what you have here, and probably would be a good idea to put a space here. You'll see this kind of stuff when you're doing string functions, whether it's building a custom string or putting in variables in a loop like we're doing here. This space just keeps the formatting correctly, because when it goes to concatenate the second variable here as a string, it will put it right at the end of this, which if you didn't have the extra space there, it would be stacked up against the S from the word is. So just add the space in there to handle that. All right, and then we'll go ahead and close the log statement. So what we have here is the very, very simple for loop that's going to run 4 times, and it's going to log this string out to the screen 4 times. And each time you're going to see this, since it's referencing the variable that we're using as the index in the loop, this is going to change each loop. So you're going to see this message printed 4 times. First is going to be the value of I is 0. Second, the value of I is 1, and so on up to 3. And then when it gets to I is equal to 4, this resolves to false, which means this will not process again. It will instead skip to the end and continue executing the script after the for loop. All right, so that's real basic for loop. There's a couple other things that we can note while we're here. One is that as long as you're operating with the braces, you can do as many lines inside of the for loop as you want. So for instance, if you didn't want to do the concatenation, then you could do a second line and just log I. So this would do it on 2 separate lines, and we don't need the extra space there.
So this would say print the value of I is, and then it would do a new line and then print the number. So you would see 4 sets of 2 lines each. But anyway, the main point here is that we're showing you can do as many lines of script as you want inside of that for loop, and you can use the variable of I, or your index variable, as many times as you want in here, as long as you're not modifying that variable. You have to be careful. If you're going to modify this, you better have a good reason, because it's also being modified here every time it finishes a loop. And you want to make sure that you know, one, how that's going to behave, because if you're modifying it here and here, that's getting 2 updates. So say you were adding something to it and then it increments it as well, you could have semi-unpredictable behavior. And then the other thing to remember is that if you are modifying the value that is used as the index, and you're doing something with it that kind of counters what the increment step is doing, then what you're going to have is the potential for an infinite loop, to where this will never test false and it would never exit this for loop. Now, if you're only going to have a single line of script for the for loop to operate, kind of going back to the original example with the concatenation, then what you can do here is actually get rid of the curly braces and just have a single indented line under the for loop statement. And this will just run this single line of script every time the for loop tests true and runs its iteration. This is not really, there's not really a right or wrong way to do it. This is kind of a preference. You probably will see most cases, even if it is a single line of execution, a lot of times people will still put in the curly braces, maybe out of habit or out of convention. A lot of studios will have their own coding standards, and some of them will require to use the curly braces regardless of how many lines the for loop is actually executing. So just keep that in mind. It is optional with a single line, but if you're going to have more than one line, then you have to have the curly braces. So we'll go ahead and real quickly put up the other case, just showing multiple lines of execution. Okay, so we'll go ahead and leave it like that, showing that there's the 2 different ways, basically single line, no braces, and multi-line, the requirement for braces. But just remember that you may always want to use the curly braces, even in the case where you do have a single line. Okay, so that's a quick overview of the for loop. The next loop that we're going to go over is the while loop.
So let's go ahead and put in our while loop heading here. Okay, so the main difference of the while loop from the for loop is that instead of kind of defining these 3 separate steps inside of the parentheses here, the while loop is just simply going to be, it's more like an if statement in that you're just checking for a true or false value. So if we go ahead and put in our heading here, throw in our braces for what we're going to do inside of it. So basically in here, it's just looking for a true or false. Now you could put a true value here, but you would not really ever want to do this in a practical use case, because a while loop is going to continuously loop forever as long as this is true inside of the parentheses. So if you're setting it to true, you've got an infinite loop basically. So you want to generally be checking against something here. But what's different is that you're not going to have the auto increment step that a for loop has. And you're also not defining the index inside of the parentheses in the same way. The difference would be a while loop is good for a type of case where you have something that you actually do want to loop an indeterminate amount of times, whereas a for loop you're iterating over, say, an array, and so you've got a fixed number of indices, and so you're going to iterate over the length of that array, checking each element. A while loop is good for type of thing where you're kind of waiting on maybe a game state change, and you want something to continue running until something that is out of the control of in the case of the for loop, the loop itself, basically out of the control of the script, and it's waiting on maybe an event from the game. And then that event is changing the value of whatever you're checking against. That's one example, of what might be here. So this could be a bool value that is being set from another function or something along those lines. But another thing you can do is we'll just do a simple kind of local case here, and you'll see I'm using the local keyword because as with all this stuff in this kind of overview file, you'd be doing all this stuff inside of a function, and so you're going to be using local to define the variable, not the var keyword. So just keep in mind all these examples are inside of a function. So local, we'll do an int. We're just going to stick with the I for now, since we don't have a particular case of what we're iterating over. And so we're going to set that equal to 0. So here, what we can do, one example would be to do basically the same case that we are doing in the for loop above, is checking for I is less than 4. In the case of the for loop, where you're incrementing I every time, we said it's going to iterate over it 4 times, basically. So here, we've got I is less than 4, but we're just checking for a simple true case. So inside the while loop is where you need to have sort of your exit condition defined, at least in the case where you have a local variable like this. You definitely would need that. Just so we could have something here, let's put in a log. So we have our log statement there. And then here, just as an example, we're going to do I. What we have here is the equivalent of a incrementing by 1, since we're adding 1 to each time. So in this very simple case of a while loop inside of a function with that's a local variable defined for what we're going to be checking against, you have the equivalent of the for loop up here, because this incrementation of the index variable is happening right here where we're incrementing I. And then, in this case is going to test false at the same time that the for loop one would. So again, just going to get the same output that you would expect from the for loop in that case above. As we go, like another example here of a while loop, another example of a while loop would be to take it and do something a little bit more complex with it. Just for an example, we'll do another local here, and we'll do a bool. We'll call this loop condition, and we'll set it equal to true. So then we have our while loop, and we're going to check against loop condition. So now we have something that could technically be an infinite loop if we aren't handling loop condition appropriately, but it's different than the case of what I first had typed, where it was just while true, which would definitely be an infinite loop. In this case, loop condition could be changed by something. So depending on what's happening inside the while loop, for instance, we could set up here. So we have an early exit condition if check, and if so, we will break out of the loop. So the break keyword here will break you out of the while loop independent of the while condition being true. That's one option for getting out of your loop. And then we could have other code in here that's doing something, doing something else, multiple lines of script here, and then we could have another check where we want to check for another exit condition. These are all fictional, but just to give you an example of the flow. So inside here, what we might want to do is set our loop condition, which is our local scoped variable. So we're inside a function, the local variable, loop condition is what we're checking against. Loop condition here, we're going to set equal to true. So we're still looping in this case. And then we're going to continue. So the continue keyword will break you out of the execution of, if there's more stuff happening below here. So we can still do something else here, but if we want to have this mid-exit condition, the continue, we're still leaving loop condition as true, but we're breaking, not really breaking, we're continuing out saying start the loop over again. So whatever we're doing up here presumably is what's setting the mid-exit condition. And so if this is true by the time we get through the execution here, we want to loop back instead of going down and finishing whatever scripting is down here. And then say you have your normal exit condition here, and all this is doing is setting loop condition to false. So just recap really quickly, this is a case where we're looping as long as this is true. We're starting out with it set to true. We have some early exit condition, which could be a variable that is a variable of the class. It could be local to this function as well that we are would be operating inside. But if that is true, we're breaking out of this while loop and saying it doesn't matter what this is, we're done, and continue on. So say this is false, we're going to come in, do something else, and then we're going to check, should we exit this loop or should we stop processing the remaining script lines down here and start
the loop again, and if so, that would be our mid-exit condition. We're setting this to true more as an example that we're still looping. This would still be true because as soon as it's false, you're going to break out anyway. But the main point here is to hit the continue, which is going to stop execution and start back here at the beginning of the while loop. So we're going to check again, do the same things. If this is now not true. Now, one thing you got to remember when you're looping is, in this case, it would be kind of an assumption that you would want to also set the mid-exit condition back to false, because whatever logic is presumably happening here that set this true, you'd want that to only happen that one time. Otherwise, you would never get past this point if you just set it to true and then left it there. So unless this is also being set to false here and some other if checks or something along those lines, the case where you did test it was true and you want to continue out, you want to make sure before you do that to set this back to false, so that this will only get tripped again if the appropriate logic was triggered. So if this was not set to true, and so we'll presume that this is false, then you're going to continue on, we do something else, and then we come down and hit our normal exit condition, which is going to set, if this was true and we wanted to break out of the loop, we would set this to true, or you could just set that variable to true either way, just kind of trying to show the idea of the early, mid, and normal execution, or exit condition, excuse me. Okay, so that's kind of a quick summary of the while loop. You're going to see these probably less commonly when you're looking through existing UnrealScript files than the for loops. For loop is, a lot more common and generally more practical in everyday use cases than the while loop, but the while loop has its uses and you will see them in use. So I wanted to make sure we talked about kind of the difference, and so you'll understand that if you see an example of that. Okay, so we've talked verbally about how to use some of the different statements and things that we've been learning along the way, the different variables inside of functions, but just verbally talked about it. Now we're actually going to get into declaring your own function and kind of how that's set up and what the options are. So this is where the heavy lifting for the UnrealScript begins to take place. So what we're going to do right now is go ahead and start out by just declaring or showing the declaration of a function. These are going to show the actual keywords and not the the words you necessarily would be using, but we'll get to an example of that too. So we'll go ahead and do our little heading here. So a function has an optional keyword, so I'm just going to type that out here. So this can be a keyword, and then you have the actual word function. You see the IntelliSense finds that. This is not required here, and you can't just start out by calling or just declaring a function. We'll get to a couple of the more commonly used keywords here at the end of kind of the overview of functions. But for now, I'm just going to throw out the whole declaration of how you can define a function here. So the next thing is going to be the return value. This can be any custom variable type, like a class that you've defined once we get into more classes, or it could just be a variable like a bool or an int. And so what you're kind of defining is what this function is going to be operating on. Not only operating on, but what the main point of the function is and what value you're expecting to get out in return. So for a simple function, this is just going to be one of the base kind of variable types like a bool, int, float, but it can be your own custom structure or custom class. Go ahead and put that in there. And then the next part of is the actual name of the function, which you can, name whatever you want, but we're just going to say name. And then you have an open and closed parens. And inside of these parentheses is where you're going to have any optional values that can be passed into the function. You don't have to pass anything in. You can declare a function with no optional variables or arguments, as they're called in C++. And what that means is that the function is going to do something, presumably on some member variables of a class, and it's going to make some modifications or do some tests, but not have to return any value. Like what the function is doing is going to be self-contained, so to speak, and you're not really needing the result of that to do anything with following that function call. An example of this would also be if the variable type that you were returning was a bool, then you may be calling the function just to test if a value is true or false inside of that class. So you could say,
call a function that says is weapon firing. And that function would then look at the internal variables to say, maybe it has a bool that says is firing. And so all the function is going to do is check and return the value of that bool. But the reason you put that into a function is for reasons of inheritance, and there's private variables in this classes that you can't directly modify or sometimes check. And so you'll use a function to kind of, as they call an accessor, to find out what that value is. But that's definitely optional, so there could be anything in here. And for now, I'm just going to put param key and then params. So this would be similar to the variable type. This would be like an integer, and then this would be the name that you were assigning that integer that was being passed in to. So then in the remainder of the body of the function, and same curly braces, just like with a for loop or a structure. Everything that this function is going to do will be contained within those two braces. Now that you have this optional param, you can refer to it, inside of the function by whatever name you define here. So if this was a bool called myBool, then you could just type myBool here, and whatever value was passed in is what you're going to be looking at here, what you're going to be accessing. Just for the sake of a declaration, I'm just going to leave that empty inside there. So just quickly review, you have an optional keyword, which we'll go over here towards the end of the function overview. You have the required function declaration, and then you have a variable type, which is going to be your return type for the function, the name of the function, and then you have optional parameters or arguments, as you'll frequently hear them referred to. And that is the basics of declaring a function. So now let's go over a couple of example functions to show you some of the different things you can do, as well as some different options that come with UnrealScript. There's always a few extra things you can do, such as multiple return values. Okay, so the first example we'll do of a function is going to be something simple, just do a little bit of arithmetic inside of it. So there's some common things you'll see, used for functions. I mean, anything can take place in a function. It can call other functions, it can create variables, you can do, as little or as much, I guess you could say, functionality or scripting as you want inside of a function. But it's a good idea just for kind of organization of code, as well as just good overall practice. Much like commenting is a good practice, breaking up common operations into a function so that you don't have duplicate code, across your code base is a good idea. So even if it's just as simple as doing some simple arithmetic, it can be very good, if it's something you're going to need to do more than once, or more specifically in more than one place in your script, then it's a good idea to go ahead and make that a function. So the reason I preface that is that the first function we're going to do here is very simple, and you might ask, why would you put that in a function? And in this particular case, you may not, but it's likely that you would want to do something like this, because even though it's not doing a lot of work, it's something that you may need to check in multiple places. And again, you want to reduce the occurrence of duplicate code. So we're going to do a simple function to compute the amount of damage based on the fire stat. And we're referencing our structure with the 4 base stats, such as fire, water, earth, and air. So we have our comment kind of heading, and you can be more verbose in the comment. A lot of people have function headings that involve multiple lines of commenting, such as like a description of what the return value is, both in type and also a verbal example of what type of reason you would call this function, or what you should expect when calling this function, as well as if you have multiple params or arguments that you're passing into the function. A lot of times people have a convention where you'll list those out, with each have their own comment about what you should be passing to this function and what's going to happen as far as operations on it. We're not going to go crazy with that, but just know that that's a good practice, especially if it's already in place as a expectation, or where you're working or what you're working on, then just know to follow that. Okay, so for this, we're not going to do an optional keyword as we were talking about up here. So we're just going to start out with function. Oops, you already see I missed the variable type. So we're going to be returning an integer. So we've declared a function, and we're going to return an integer, and then we're naming the function. So now we have our params. So what we're going to pass in is 2 different values here. We're going to do an integer and what we're going to call that is the base damage. So we're assuming that this there's some base damage for an ability that the player is casting or using, and then you've got your stats that we defined in the structure that work as modifiers, like basically a buff to that. So we're going to just assume it's very simple, that you have a base damage value, that this ability does some base damage, which is stored off somewhere, so you can easily reference that and pass it into the function. And then we're also going to have the fire stat. So inside here, what we're going to do is we're going to take base damage and we're going to multiply that by the fire stat, since we're treating this as a buff. So we can do this a few different ways. Let's start out with the simplest way and most straightforward. So we're going to set base damage. Whenever you pass values in as parameters, the function has a local copy of that, so you can use it and modify it without worrying about modifying the actual value of the variable that you passed into the function. So when you pass something into a function, unless you're using specific keywords, you're getting that by copy and not by actual value. So we can do this and change the value of it without worrying about messing with anything outside of the scope of this function. So we just do something as simple as base damage multiplied by fire stat. Now, another thing that you can do here, if we go up to, go ahead and put our semicolon in, let's forget that. If we go back up to where we defined the structure, you've got this element type rating, and we talked about how you can have as many variables as you want in here. What we're doing with this function right now, as it stands, is we're just passing in the integers. So presumably when we call this function, we would have said compute fire damage, and we would have said, passed in some base damage value. Could be the same name, could be something different. And then we were doing my stats dot fire, which you can see is right here. So we've been, operating on this. So if we had defined a MyStats, or you had a local member variable that was this element type rating in MyStats, and you get fire. So by calling it this way, we're actually passing in the value of the fire stat directly to the function, which matches because here we're looking for just an integer value. Another option is if you wanted to write, say, a more generic function than just compute fire damage, it could just be compute damage based on stat. You could, conceivably write a function that was like compute damage based on stats. And here, you would actually be passing in this as a variable type. So if we copy that and paste that down here, and then we'll change this to, my stats, just to keep with the naming. So then here, we would basically need to do exactly what we did here when we called the function. We would need to be referencing the member variable or the structure variable of fire inside of my stats, which is what was passed in. So again, just saying there's multiple ways you could do this. If you wanted to make this function more generic and you just wanted to say, pass in my stats and then pass in the base damage and do the multiplication, then you could have additional logic inside of this function, which was checking for, what the current ability was from a type standpoint. If that was the case, you'd probably need to add an extra variable, which was the enumeration. Or actually, we'd never defined an enumeration for this, but we could easily do, just like we did for the enum of the developer type, we could define another enumeration which matched the fire, air, water, earth. And then in here, you would basically pass in a value to the saying which stat you're wanting to basically use as the modifier. And so, you could basically add a third argument down here, and it would be the, enum stat, or I'm just making this up on the go, but you could be passing that in, and then here you would be checking inside, doing an if check to see like which stat is it. Okay, or it would probably be a switch would be a good flow control statement for that. So based on the 4 different stats, you could switch on it and have 4 different cases that would check the appropriate variable. So kind of getting a little abstract here, not really important, but I just wanted to make sure it was clear that you can pass in your own custom types, variable types, or classes, or structures. It doesn't have to be one of the provided, kind of default variable types in UnrealScript. But for simplicity, we're just going to keep this as we had it. going back to what we have, we had base damage passed in and fire stat, and just assuming a very simple formula, this would obviously generate a very high damage amount based on your fire stat if we were doing just simple multiplication, but this is totally valid. And then what we would want to do is return base damage. So we've said take my base damage and set it equal to base damage times the fire stat. So if this was 10, you'd have a multiplier of 10, which might actually make sense if it wasn't a scale of 0 to 100. If this was a scale of 0 to 10 and you were just treating it purely as a multiplier, then that would actually be fitting. It's kind of all on how how your game was balanced and what range of tuning and types of control the design team wanted to have over how this stuff was generated. But going back to this, we just are basically doing a simple multiplication, catching that value inside of base damage. So we took it and then we altered it. And you can do this because it evaluates what's on the right side of the assignment operator first. So it's going to take this as the value that was passed in and then multiply that by the values passed in and then set base damage equal to that operation. So going forward, as we refer to base damage here, it is now the value of this operation and not what was originally passed in. So that's it. Right there, you have a simple function that would take your base damage value, multiply it by your fire stat, and then return that value. As I was saying, this seems like a very simple function, and granted, you may not put this into a function if you only ever needed to do this once or even twice, especially since it's just doing simple arithmetic and not doing a complex series of checks that would be hard to remember or hard to duplicate somewhere else. But in general, it's kind of good form because you just create very readable code when you're writing something and say the player triggers an attack and you've got a function that's like generate ability. I think that's one we named up there. And you do something in here, and then after that you want to compute the fire damage. So you would call our new function and pass in your arguments here, or params as they're referred to in UnrealScript frequently. And then you could say there's another function that is actually apply damage to target. So, and then the other thing that's cool about functions is that not only can you call a function within a function, but you can also technically kind of pass a function as an argument. And that's not really true, but that's what it looks like when you use it. So let's go run with another scenario here that this apply damage to target takes a single integer value. We know that compute fire damage is returning an integer value. So instead of having, that simple integer value, so we caught, let's just go ahead and do this. Amount damage is equal to compute fire damage. So right here we were calling the compute fire damage function. The returned integer value would be stored or saved into this variable here, presuming that this was an integer. And then we could take this value and pass it into this function if this function was looking for an integer. What's kind of cool, and you have to find the right balance on this type of thing of what's the most readable. Sometimes being explicit with it and saying, this line is doing, this operation, and then this line is doing a separate operation is fine and it may be more readable. But just to be clear on what you can do, there's no reason that you couldn't do this as long as you are passing in the appropriate parameters, because this function returns an integer, and the way the script compiler is going to handle this is that it will call this function and complete this function, which is going to return an integer before this function is executed. And so it's going to take that return value as the value passed in. So it's doing the exact same thing that you were doing here by storing the value and then explicitly passing it in as a variable. Instead, you're basically just sort of making the return value transparent and passing the return value directly to the applied damage to target. And if you don't have anything else that you're going to do inside of the function with this output number, then that might make sense. If in addition to apply damage to target, you needed to do any additional function calls that needed to know the amount of damage that was applied or passed to the preceding functions, then this would not make sense, because you really would want to cache it off into this variable so that you could reference it multiple times. Two ways of doing it, and sometimes that way is more clean, but in a lot of cases it's more readable to just be explicit with it, even if it is a few extra lines of code, or it looks like more code than you need. It might just be better that way. Like, there's always kind of that debate of consolidating your code as much as possible, but you can make things so abstract that it makes it very hard to read. And so either if you come back to your code later or somebody else comes to look at your code and needs to try to fix a bug or add some new functionality, it's become so cryptic that it made sense to you at the time, and technically it functions, but it's really hard for somebody to kind of decipher what was going on and work through it. So sometimes being kind of line by line explicit is the better way to go. Backing up here, just talking high level about how you could use this stuff, going back to what we have here, and that's your basic kind of function in a nutshell. Really quickly, before we move on to some of the things I wanted to show you, I'll go ahead and put this here for reference with the comment of or. So what you could do here is just the way that the operators have been overloaded in UnrealScript, and you'll see this in C++ too. This whole line can be altered by saying, instead of multiplying that there, you can just say times equals or multiplies equals, and there's an operator kind of overload that they've written into the script that will handle this and know to take this value, multiply it by this, and then save the value here. It does the exact same thing as this line right here, but you just save a little bit of typing, and it's pretty clean. And this is one case where it's not less readable in any way. It's once you're familiar with how the operators can be overloaded, and it can be plus equals or minus equals or multiply equals. And then there's yet another option, which is even cleaner or simpler, which is that you don't even really technically need to catch the value, since you're not doing anything else with it. Kind of going back to what I was just talking about with the function kind of passed as a parameter, or passing the return value of the function as a parameter directly instead of saving it off. You can kind of do the same thing here, because in this case you're not doing anything else with base damage in the context of this function besides passing it. So you can really just go with what we did up here, change this to times equals, and then you don't really need this because all you're doing is kind of passing that. So what we're going to do here is cut that and paste it in there, and we're just going to simply return the value of this operation. In that case, you don't even need the equal sign, because the only reason we needed to save that value was because we were going to be passing it or returning it on a separate line of execution in the script. But in this case, when we're just modifying local variables, we don't need to save the value. All we care about is returning the result of this multiplication operation. Then the cleanest way is this, and this is what you'll most commonly see. This is a good way to kind of learn and understand the flow and how the return statement works and how local variables work. But at its core, this is the cleanest and simplest way to do it, and all three of these would behave the same way or have the same outcome. Okay, so in addition to just the basic function kind of declaration that we've gone over, there's a couple of optional param keywords that you can use. I wanted to cover one of those really quick, and it deals with how you would have multiple return values if you needed it. By default, a function will always just return with the return keyword whatever value type is defined right here as the variable type for the function. So you're going to be returning a single integer. There is a way to return multiple values, and that's using a param keyword. So we have here a function called increment stats. One way to do this would be to actually pass in or tell the param declaration that it's looking for, that structure that we defined up higher in the file. That's going to just pass, by copy, by value, that structure, and then you can increment each individual component of that inside the function. But if for some reason, say you didn't have that structure, say we'd never defined the structure and we were just kind of managing 4 independent variables, which is very possible. In that case, you could have one function increment all of them, but since it doesn't pass by value, it's passing a copy, we need to actually return the value of the changed. If you're used to programming in C or C++, you have the option to pass the reference to the variable, and you're actually changing or altering the variable that you passed in as it exists in memory, and not a duplicate value that gets copied when the function is called. But in UnrealScript, you're always operating on that copy. So what they did was they added this keyword called out. And so you have this, So right here, what we have is a way that we could increment our stats, and we'd be passing all 4 individual stat values as they exist in that structure. And then we could do, just whatever arithmetic in this case. We're doing a simple incrementation, so we can just do a plus equals 1 is the way to increment something. And we can do the same thing. One thing I like to do in programming is keep similar rows where you're doing a lot of the same operations. You can just tab them over and line them up on a tab order. The white space is allowed. So right here, what we have is, that's it. The function's done. It's going to actually take these values and return them back to the function when it's done. So you have basically four different return values by adding this output or out keyword to the param. So that's how you would return multiple values as opposed to the default one. That's it for functions. What we're going to do next is go over classes and how those can have their own internal functions. How you can create your own variables that are member variables of that class, as well as inheritance. Okay, so here we're back looking at just a super basic class. This is basically me just creating a new class using the add new item option here and doing an UnrealScript file, and the infringe tool kind of auto generates this base class structure for you, defaulting the extension of the object class. Basically everything in UnrealScript is an object that is core, that is like the lowest level base class, so to speak, that everything is in some way, form, or another derived from. But we talked about class structure just a little bit briefly when we were going over the overview file here when we first started kind of filling this out. But I wanted to come back to it just quickly because I wanted to talk a little bit more about class inheritance using the extends keyword in UnrealScript, and also just to revisit a few different things just to make sure that we covered kind of how the classes are set up and how those work before we start looking at what I want to do is kind of go over a couple of the somewhat commonly used UnrealScript files, or at least objects that you're commonly using in the editor when you're building levels, and kind of show you how the inheritance has worked in those cases, how those files were structured very intentionally for the expandability of different object types if you want to add additional mesh types or different lights. And it's also good, as I was referencing earlier, also that just looking at the UnrealScript that has already been written, there's just thousands and thousands of lines of script here, and a lot of that you can pick up a lot just by looking at what's been done. Some of it too is very very complex and maybe a lot more in depth than anything you're wanting to mess with. There is a lot of functionality in UnrealScript that goes very deep and can go pretty low level. And you may be looking to just do more kind of modifications or adding a few new object types, but not really looking to do really heavy lifting stuff. And that's generally going to be fine because a lot of that stuff is already done for you with the stuff that's available kind of out of the box with UDK. And what hopefully you're going to be doing with this is maybe tweaking stuff, kind of modding what's there, tuning. I mean, you could come in here if you wanted and retune the weapons that are available, the different Unreal Tournament weapons, and make your rockets 100 times more powerful and just kind of play around with stuff. And it gives you a really good understanding of the relationship of objects and how that stuff all kind of works together, but you're not necessarily going to be getting in there and writing some super low level stuff. So again, just super basic here. We've got the class declaration, the name of the class. You have the extends keyword, which is specifying then what class you want to extend from. Everything, like I said, in Unreal is kind of derived from object. The other common class you'll see things derived from is actor. And if I switch over to this file right here, you can see they even have a kind of a unique comment here that says this is the base class of all actors, which is the base class of all gameplay objects. And this is really important. Basically, the actor class is what and you see it extends from object here, but the actor class is what gives those gameplay objects the core values or variables that they need to exist in the game world. If you scroll down here just a little bit and start to look at some of the member variables, you've got a vector, which is 3 coordinates for location, rotation, scale. These are kind of the core things that all objects in the editor and the world need to have, and that's kind of apparent with the actor class. Of course, it has as you can see, it's a very large file. It's probably one of the biggest files in all of this code base, but that's because actor can cover a lot of things, and so they've put the stuff that's just really core to any object. Even if not all objects touch all of this stuff, obviously they wouldn't, but if they could, or some variation of an object will need to know this stuff, then it makes sense for it to be in that base class. The reason I wanted to show this, even though it's a huge file and it's a lot to take in, is it is really kind of pivotal to understand how the inheritance works. Is that when you extend, so if we change this right now to be actor, so now this example class is extending actor, we have all of this. Everything in this file is now basically part of our object. It can be a bit overwhelming because there's a lot to kind of absorb here, but you now know, for instance, that your object right now, if you just compile this, even with no additional variables and no default properties, this is an object that when placed in the game would technically have a location and a rotation and those core properties. Now, of course, it doesn't have anything to actually do anything with. An actor needs to have some sort of special implementation to kind of define any sort of usefulness. But the way the inheritance works, if you're not used to that from general programming like C++ or Java, basically this object now is an actor, but can have its own additional things. So anything you add in this class, we've gone over variables and enumerations. So if you're declaring variables in here, now this class has something unique that actor doesn't, and that is myInt. And in the default properties of this, you can set myInt to some default value, say 12. And so now any existent or placed version of this object of this class now has something unique. It has this variable that has the value 12. Of course, you have to do something with it, but it's kind of cool that you have this much power just by using a simple extends keyword. And then, just to make sure we've covered the structure, a lot of the stuff we did in the overview class actually is perfectly applicable to a class. You would be defining your functions, and maybe we're going to have this return, bool, and we're going to be doing our work in here. So all the stuff that we went over with functions, doing enumerations, the structure, all that stuff can become part of this class, and this class now has those variables and that functionality built into it. And if you were to write a new class that extended this class, then it would inherit all of the stuff that is in here and automatically have that, and then you could continue to add to it. We didn't really cover, I don't think, the default properties too much earlier when we were talking about variable declaration. Basically, this is kind of a unique thing to UnrealScript that I don't think you'll really see in any other programming like Java or anything like that. And in C++, you would just have the option to initialize the variable when you declare it to some value, but that's not valid in UnrealScript, and the default properties take the place of that. The best way to think of this is, in my mind, is like an init function. Whenever this object is placed or created, then the default properties kind of get called as part of the initialization of that object. And that way you're getting all these variables essentially initialized, so that any work you're doing in functions that refers to this, if you've got it set in the default properties, then it's essentially initialized at creation, and you can safely do things with that variable. So this would be valid because this does have a value. This has the value of 12 by the time it gets to this function. So default properties, if you look at other classes, and we're going to get to that in just a sec, you'll see that a lot of the variables that are unique to either that class, or in the case where it extends a base class, but if you've got, like, say, a single base class that two objects are derived from, and each of those objects does little to add new functionality or add new variables, but it's more just a different default state, then a lot of what they're going to have is just different default properties. But the actual work, and as far as new functions or new variables, may be limited or none. It's just a way for you to kind of set that default state. All right, so let's go ahead and bounce back over here to the actor file. Just going to kind of scroll through here and just highlight a few things that are good to know. Like, this is kind of going even beyond UnrealScript. This is just getting familiar with Unreal. If you've worked a lot with Unreal on the editor side, you've seen a lot of this stuff in properties. For physics objects, you've got the different phys states, and you'll notice that this is an enumeration, which we've covered, and it's a constant. They got the keyword in there saying, like, this is a constant, like, this does not change, and that's very important for the game to know, because this is in the actor base class, which every object nearly is going to derive from that. So you need to know that they're all going to have that same consistent enumeration, so that you can refer to that across all files. We've got more enumerations, and you've got a structure here, like we talked about structures. And the other thing that is kind of interesting here is as you scroll down, you'll start to see a lot of this, like the networking flags, and this is all dealing with replication for networked games. And there's just a lot of stuff here. And this is kind of where I was saying, like, when we were talking about variables, like, there's a lot of keywords, you'll see a lot of consts, but you've got things like transient and these just different kind of special isolated cases. And in a lot of cases, you're not going to need to deal with that if you're not dealing with networking or anything like that. It's all good stuff to know, but it's just a lot to take in and not really critical just to get the ball rolling. So actor, like I said, is a huge, huge class. But if you look over here at static mesh actor, this is a good example of a static mesh actor, of a class that is gaining a lot of functionality based on inheritance. And this class, though, is a lot smaller, right? Like, you got your default properties down here, and you got a couple of variables that are local to this, this class. You also see the CPP text identification here with the brackets. This is basically saying that these are functions that are actually written in C++, and this provides UnrealScript with an interface to call them. But you notice we don't actually see these functions. And with UDK, we don't have the CPP files available to us, so this is not something you can go edit, or even in this case go look at. But it kind of gives you an idea of what functions are available to this object, even though you don't have the actual implementation. And the reason for having the implementation of functions be in C++ can be for different reasons. Sometimes it might just be scope of what that function needs to do and what it needs to manipulate is just not friendly to UnrealScript or not accessible or in scope, and there'd just be too much work to get that in scope, so it's better to write the function in C++. Another reason is performance. If there's a function that is doing a lot of work that is performance intensive, like a lot of ray casting, that stuff is going to be faster in C++ than UnrealScript, just pure performance of how it works. C++ is a very fast language. That's why it's used in games so prevalently, and UnrealScript is designed to be more about speed and iteration, but its performance is going to be less than CPP. So, but it going back to just the whole inheritance thing, it's interesting, I think, to see that a static mesh actor, which is so heavily used when building out worlds, has a pretty simple looking script file, but that's not that there's not anything to it. It just means that it's kind of stored elsewhere, and it's just picked up a lot of functionality. So, for instance, you notice that static mesh actor actually extends static mesh actor base. So it has its own base class instead of deriving directly from actor. So if we open up that base class, you'll see that this, again, is a pretty small file, but it extends from actor. And so really, with the exception of this one file that is actually written in C++, you've basically got just a setting of default properties for the static mesh actor base, so that any new mesh actor class, so if you had, you wanted to create a new mesh class, you could derive it from static mesh actor base, and you would know that they would have basically a consistent default setting when you place that object in the editor. But you can then go and add your own additional things. In this case, it's adding its own static mesh component, which is going to give it that actual renderable object in the editor and in the game. So static mesh actor base is very little, or a little more than just a default actor, which is not useful. It really, gives you that location, but it doesn't give you anything to draw in the editor to see or to manipulate. And so, just extending that class, which extends actor, and then adding this static mesh component, you've now got that renderable object. And static mesh component is a whole other, set of inherited objects that has a lot of stuff to it. But you don't really, need all that stuff. You just need your static mesh to have that renderable object. Another thing that we'll look at is the trigger class. Triggers are obviously used a lot for scripting gameplay. Unreal has a few different trigger types. There's an actual trigger object which has like a cylindrical collision and is represented by a sprite in the editor. And then you also have like the line of sight triggers. And then you have the volumes, which are generated by the brushes like BSP. And you can do triggers off that. In this case, this is the placeable trigger that is, a cylindrical collision. It's really cool to if you've worked on the editor side for any amount of time and kind of familiar with the objects, to then come and look at the files that generate those and see a lot of the stuff that you're maybe familiar with. And it's like, oh, that makes sense. That's why it's like that. For instance, you've got this trigger, and right here you've got an event called touch, which is looking for the sequence event touch objects, which are Kismet objects. And we'll get into those here in a second too. We're going to talk about those, but this is where, it's looking for that associated touch event in Kismet, or, in a sequence event that's been placed in Kismet that you're listening for essentially. And this is what's going to notify it that it's been triggered. And you've got the notify trigger function, and you see this a lot where, a simple event calls a function that may actually be defined in that same file, but you don't know where else you may need to call it from, and that's where it makes sense to kind of encapsulate it into a function. So, and then this one you'll also see kind of a large default properties. One thing that is worth highlighting here is default properties can do more than just set member variables. It can actually create objects. Like I said, it's more like an init function than maybe how default properties might read. So in this case, this trigger is going to have that sprite object in the editor. So when the trigger object is created, when a new object is created and the default properties are called, or the init is called, you've got this begin object. And what that's doing is creating a new object, which is of class sprite component. And you see the different properties here. It's given it the texture to use as the actual sprite. And then it's adding it as a component to this trigger object. That's not the most clear thing, but basically this bit of script right here is what is giving you and defining that sprite that you can now see in the editor when you place the object and use to select it. And so if you wanted that to have a different sprite or a different icon, you can come in here and you can edit that. You also see that here is where it's defining, as I was saying, the trigger uses a cylinder for its collision. If you're not using the brush trigger type, just this object uses a cylinder collision, and you can see it's creating that cylinder component here, setting up its default values for radius and height, and then it's adding that component to this object as well. So there's this concept of components, and you can add as many as you want to the object. And those are based off of these different begin object and end object. So you'll see really a lot of the times the best way to learn this kind of stuff is when you want to add something new or alter something that is already existing, is especially in the case where you want to add something new, try to think of something, an object or an existing class that does something similar to what you're trying to do. We're going to go over some Kismet, how to create your own Kismet actions and events. And that's a really great example of like most of the stuff that you're going to do because of the kind of confined set of things that, an action or an event can do in Kismet as far as inputs, outputs, variable links, that's all pretty consistent. And so you can go look at existing classes and see, how they did something and copy and paste that, or at least use it as a learning tool. And that's a really good way to just kind of pick up on stuff. And as you do it more and more, you'll start to build more of a mental map of where stuff is and how stuff relates and where some of the dependencies are. All right, so another thing real quick I wanted to show was, again, related to Kismet. You'll see the supported events. And this is another Kismet action. Anything that has a sequence, event, or action, or there's also a condition, that's kind of the naming convention to define Kismet classes. So this is adding support for that Kismet object. Here's the light class. I wanted to show this really quickly because this one does derive directly from Actor and does provide, some base functionality. Again, most of it is actually written in C++. You've got some stuff here for replication, which is for that networked stuff. Here you've got function that's going to handle the toggle, which is a sequence action here. So you've got a passed in Kismet class here. The toggle is kind of a generic thing in Kismet, if you're not familiar with it, that can basically toggle the is enabled flag for just about any type of object that has that supporting flag. So you can call toggle on a light and it will turn the light on or off. You can call it on a trigger and it will turn off whether or not the trigger is active. So it's really just kind of a general purpose, and that's how they handle it. And then you've got your default properties. Again, same thing. It's adding a sprite here, which will be the editor object for that light. How you select it, see it, and then but not a lot going on. Not a lot of additional stuff besides what is in Actor. But then you've got your specific light types like a spotlight, and you can see that derives from light. So you've got Actor, and then you've got a light object which derives from Actor, and then you've got a spotlight which derives from light. So it picks up all that toggle functionality and the different functions that we saw in there, but then it adds some of its own stuff that is going to be specific to a spotlight. And you can see that kind of clearly here with the different radius, inner cone, outer cone, stuff that only a spotlight needs to know about. And then also you've got the idea of the light component itself here, which is going to be new because of the different casting shadows and stuff like that. Also, you've got an arrow component. This is kind of a generic class that you can add as a component to any object. So you'll notice many objects or scripting objects that you place in the editor will have that arrow component indicating direction. This is how you add it. It's really simple. Again, this is a case where if you're creating a new object and that you want to have an arrow indicator, it's very easy just to go find a class that has one as well and grab this as an example. All right, so kind of quickly jumping around there, but that's kind of going over how quickly you can go from Actor to something like a static mesh or a trigger or a light or even a specific type of light. And that's all kind of just basically extension all from this keyword and that class hierarchy. Some things that will get a little confusing when you want to do something specific, like say you want to add a new weapon. You might want to make sure that you kind of do some looking around and take note of how the hierarchy of weapons is, because some of it may not be as clear or as straightforward as you might think. For instance, some weapons are considered instant hit weapons, which use a raycast to detect whether or not they will hit their target. And that's all done, in a single frame, whereas other weapons will fire projectiles, which are simulated and have an actual, duration and a life. So those weapons have kind of different paths of extension in the class hierarchy. And so it's just good to make sure that you kind of take in what's there, do some research, and make sure that when you're adding a new weapon, you're adding it in the most appropriate place. Because what that's going to do is if you're using the inheritance right, then you're going to minimize, well, in some cases it'll be the only way to do it, but you're also going to minimize the amount of work that you have to do in your class, because a lot of that functionality will already have been written for you. And so what you really need to do is just find that kind of right chain of inheritance and say, okay, I really want to inherit from or extend this class because it's already doing everything I want to do, with the exception of I want to change the particle effect and the amount of damage it does. If that's all you want to do, then you don't really need to do a lot of work. You can just find the object that's basically that same thing, extend it, override its default properties, and you've got a new weapon that does what you want, has maybe some slightly different tuning. Okay, so that's kind of a quick run through on classes. Next, we'll still talk about classes, but I wanted to talk a little bit about the Kismet stuff and how you can set that up, because Kismet's very powerful in knowing how to add or even just look at what is there. I know when I was learning Kismet, there was a lot of unanswered questions for me as far as like what was valid or how this was intended to work. And looking at the UnrealScript was a great way for me to kind of understand that and, kind of educate myself on the Kismet side of what can do what and what's better suited for certain applications.
One thing I wanted to highlight really quickly before we get into talking about creating your own custom classes and extending existing UnrealScript functionality or writing your own new stuff is I wanted to talk about kind of how the file structure in Windows, like Explorer, for instance, needs to be set up for that. So you'll notice over here in the Solution Explorer that I have a folder that is the same name as the project, though that is not required. That's just kind of my convention, but you have to set this folder up manually as well as putting a folder inside of that called classes, and then that's where you want to store your custom script files. You can see I've got a couple here, and we'll go over adding these here quickly, but I wanted to explain that you need to set this up manually, and I'll show you here inside. If you go inside your UDK version, you'll have the different subfolders for the different versions if you have more than one installed, and inside the development and the source folder is where all of the UnrealScript is stored. Earlier when we set up the solution, you remember that Visual Studio automatically put it in a subfolder, and we actually pulled that back out and put it here at kind of the top level source directory. And then what I did was create this this E3D UnrealScript folder manually, and then manually created a folder under it called classes. And you'll see that follows the convention of all of their other. They will have some files in here, although this is a rare occurrence, but generally it's always the classes, and this is where all of their files are stored. As you can see, there's many, and this is just in one of the folders. There really is a lot of existing UnrealScript. A lot of the game play and stuff for Unreal Tournament and Gears of War and all of the other Epic games are really driven heavily by UnrealScript because it's the nature of the way they've architected it. So after you've set up these two folders, there's one other thing that you need to do so that when you are building or making the UnrealScript, which can be done from Visual Studio using the Infringe plugin or the IDE, but you need to make sure that UnrealScript knows about the new folder you've created. So I have another Windows Explorer window here, and you can see, I'll back to the root folder here of the UDK installation, and we were in development source there for where we were storing it. But here inside of the UDK game folder, there's a config folder, and this has all of the INI files, which are the configuration settings for everything from the editor to the game. As you can see, there's a kind of a wide range of different default files, even down to weapons. And so we're going to open up the UDK engine. And here, we're going to do a search for edit packages. So we're under the heading. If you'll notice in the INI files, it kind of have different groups or areas that each have their own heading. This is how the engine defines kind of what commands it finds or what lines here, how they're applied. So this is applying this to the editor engine. And you'll see there's all kinds of different things. You can look through these INI files and find all kinds of interesting settings and things that you can tweak and tune, although be careful because you can also change the settings to something that will break your editor and cause it not to load until you can figure out how to revert your changes. So edit with caution. But what we're looking for is the section here on edit packages. So you'll see here that there is this edit packages in path, and that's our development source. And then each one of these edit packages, you'll notice, corresponds to, if I go back to the source folder, sorry, let me back up, go to UD game, and you see script, you're going to see these files here. These are the .u files. This is like the compiled version of the UnrealScript. And you notice that these names, most of these names match something that is right here. So this is kind of defining the packages that it's going to create. The term packages can refer to kind of a lot of things in Unreal. It can refer to a package which a asset or a number of assets are stored in, or it can also refer to a .u file, which is the compiled version of a .uc file, or a collection of .uc files. So what I've done here is added this additional line called, with the keyword in front of it, mod edit packages, and then set that equal to the folder that I created. You technically don't have to have the mod. Edit packages would work as well. That's just kind of the recommended convention when you are creating, a modded version of an Unreal game or creating your own project, that you kind of keep it separate just for clarity and for readability. So added that line, saved that. So now whenever you're here in Visual Studio and you go to build, it's going to kick off your project. If you go to project properties, and we'll, sorry, not the solution, the actual solution or project. You see the UCC path here gives the executable that we're running. And if you look at the build, here's what's actually being basically generated. The command line is taking that executable that you specified, and then it's running a make command on it with the debug flag. And so this right here is basically looking at that source folder and compiling all UC files that it knows about. And what we edited in that INI file was here in UDK engine is what enabled the make command to know to basically look through the folder and inside that classes folder and grab any UC files that are in there and compile those. And so now if you look at the script folder, I've already compiled this. I now have an E3D UnrealScript.u file. And it's very small because I haven't really added anything, but this is the compiled version of any custom scripts that I've added for my project. So another example of a class that you can extend in UnrealScript is the Kismet related classes. You're probably familiar with Kismet as the higher level scripting language, the visual scripting language that is available in the Unreal Editor. And so one of the great things about UnrealScript is not only can you write your own custom object types that can be placed in the editor and used in your levels, as well as do AI logic or weapon logic. So you can really kind of shape the whole game from UnrealScript, but you can also alter the Kismet environment for your project and add custom functionality. Examples that when you'd want to do this would be as if you add your own custom object type, for instance, say a custom trigger or custom mesh type, that you would then need to be able to manipulate that from the game environment while the game is running, while Kismet is running at runtime. And so you could write a custom Kismet action or event that would coincide with that object that would allow you to reference that from your level scripting. So anyway, I wanted to go over quickly how you set one of those up. Infringe makes that, the IDE that we're developing in makes that easy to do by kind of giving you a starter stub of a class similar to how it did here for our base class, our basic class. So if we right click on this class's directory that we created and we create a new item, Infringe is going to kind of give us these default Visual Studio templates, and you're going to see a variety of Kismet files as well as our kind of default UnrealScript file that we already went through. And so you've got a Kismet action, a condition, and an event. Those are kind of the three main things. There's also a UI scene which uses some of the same Kismet visualization code, but is a separate kind of editor in itself, and we will be getting into that. Basically, if you're not super familiar with Kismet, the action, the way you think about that, or the way I like to think about it, is that an action is when you are going to act on any object in the game at runtime. So this could be an object you place in the editor, like a physics object or a trigger, even just a static mesh if you wanted to change the mesh that it's using. You can do stuff like that all through Kismet at runtime. A condition is more like your logic flow, similar to the logic flow that we've gone over in UnrealScript, such as your if statements and your if-else statements and the different comparison operators that kind of exist, such as greater than, less than. All of those things are available in Kismet still, but they're kind of wrapped up into this condition block or a set of condition blocks. And then a Kismet event is when you are kind of listening for an event from the game at runtime. So an action is when you want to perform some action, manipulate some object, change something, presumably in the game state. An event is when you're listening for essentially the right opportunity to do that. So if you set up a trigger in your game environment, when when the player or a character touches that trigger, you have the opportunity to set up a Kismet event that will be listening for that, and you will get an event that fires and allows you to execute some Kismet logic at that time, which would generally be followed by a series or even just a single Kismet action that would do something because that trigger was activated. And the conditions will be kind of interweaved throughout those actions to make sure whether you want to continue down that logic path. All right, so what we're going to do is just go ahead and create a Kismet action right now. So as I mentioned, you can see that Infringe kind of set up a default class for us. It just defaulted the name to sequence action 1, which we'll want to change. And it extends the sequence action class, which is correct, and we want to leave that. I can't think of too many cases where you would actually need to have multiple kind of inheritance, so to speak, or levels of inheritance for Kismet actions. Generally, everything is going to just drive off sequence action, which gives you all of your rendering functionality and your input and output link arrays, and all you have to do then inside your class is kind of define how you want to add to or subtract from what is available to you. The thing that you're going to notice right away is that's different from the example class. I mean, we put our own function in here, but it didn't come in from the default setup. Is there's already this event called activated that's put in here for us. This is your primary kind of workhorse for a sequence action. This is what's going to happen whenever an input is fired or triggered. And you'll see the terminology has impulse used throughout Kismet actions and events and conditions. Everything has the idea of this impulse. There's inputs and outputs on a Kismet block, and either an input or an output can have an impulse, which essentially is saying it's been activated. Inside this activated event or function, it operates like a function, is where you're going to be putting your logic for what happens when your Kismet action is activated or triggered from some flow of logic. And it still has the same default properties that a normal class would have, and it puts in the defaults for you here for object name and object category. And the way these work is that the object name is going to be the actual name of the Kismet action. It'll show up in the the header of the Kismet block, as well as define the name that will be what you select in your right-click menu for adding new actions. And then the category is just that. It's a category in that right-click context menu. So let's go ahead and open up the editor now that we've created this. We're going to have to build our scripts really quickly. So we'll do that. And as soon as this is done, I'm going to go ahead and open up the editor, and then we're going to take a look at our new Kismet action, which admittedly will do nothing right now, but I want to show you how it's added it to the UI. Okay, so the editor's loaded up, and we've got kind of the default start page here, and we're going to go ahead and close that because we don't need that right now. And we're going to open up Kismet. Here in Kismet, if you haven't looked at this before, basically you have your different panes down here. By default, you'll probably have the sequence pane here, and for what we're doing, we don't really need that, so I just kind of hid that. But you've got this pane here where you can add all of your Kismet, and you've got the right-click menu. So if you right-click, you're going to see new actions. Also, you'll see an entry for Matinee, which is kind of separate from what you're going to be doing in UnrealScript. Matinee is its own editor, so to speak, and for how to manipulate objects through keyframing and stuff like that. Well beyond the scope of this. We do talk about that a little bit in the intro to Kismet. And then there's the conditions. There's a section for variables and then events. So obviously you have the action, condition, and event that you saw as the different class templates. And then variables are just that. These are the different variables that are available. Stuff that is available in UnrealScript like bools, floats, ints. And then they also have, like a custom player object, just a generic object, which can be assigned different things, and the vector class. So what we're looking for is actions right now, and you're going to see that we now have this new group called Unreal E3D UnrealScript Actions. And getting a little bit of a weird UI thing here, but let's start over here. So there you go. You got this is the category, and this is the name. So if we bounce back over to the script file, there you go. There's the name of the class, and there's the category that was defined. And so that's exactly what we're looking at right here. So basically, if you're adding a new Kismet action and it fits into an existing category, then in that default property, you would just edit the string that is defined there to match an existing category, such as an event or maybe an actor, or if what you're doing is operating on something with physics. There's a physics category. Basically, just whatever makes sense, or you can define your own. Like you'll see here, they have demo game, which is sort of just for demonstrating some things that you can do with Kismet, but not necessarily something that's in a shipped game. All right, so let's switch back over to the script and make some changes to this actual class. I'm going to go ahead and shut the editor down because in order to pick up the changes, we'll need to reload it after we're done making them and can compile the script. So here we are back in the sequence action class. Before we go in and actually start editing here, I'm going to open up a couple of existing objects to show you kind of what exists as far as like that base functionality that's kind of coming from the sequence action class, so that you don't spend a lot of time writing new stuff. So if we open up the engine folder here in classes, and we scroll down to the section with starting with S, you're going to see a large list of sequence actions. Here we go. So everything starts with this prefix sequence action or seq action, and there's also conditions and events. The conditions are like we were talking about, the different comparisons and the logic kind of operations. So the first one I wanted to open up was the sequence action gate. This is a commonly used Kismet action when you're doing scripting logic in Kismet, because this is how you do it. This is sort of like one of your if checks that can be checking against a bool value or different values. And then the other one I wanted to open up is a comparison, and that is the integer. All right, so I'm drag this over here. So let's take a look here. If you look back here in the editor, you'll notice that I'm going to go ahead and drop an instance of both of these blocks, and so you can see what we're going to, what is there visually if you're not familiar with it. And so that way when we're looking through the script, you can kind of start to match some of that up mentally. So let's go back over to the editor. Okay, so if we open Kismet back up, and we'll go ahead and drop in an instance of both of these two classes that we're going to look at. The gate is located under the miscellaneous section of actions, and the comparison for ints is under conditions, the comparison category. All right, so here are two objects that we were just looking at the class files for. So I wanted to highlight a few things so that you could see these kind of in action in the script and make that connection. So the gate by default has 4 inputs. You've got the in, just the basically activate or check this gate, and then you've got the single output. So the logic flow is to come into in and then go out if whatever condition of the gate is true. There's an internal variable called open, and this is defining whether or not this gate is a pass-through. So it's basically saying, is this true or false? So you can open or close that, and that changes the value of this open variable in the UnrealScript file that's driving this. And you can also toggle it, which will just do exactly that, toggle it true or false. So whereas if you were doing a comparison for a bool, see here you'll see kind of the opposite, where you have a single input and one or more. As you can see here, you have a lot more, 5, but a bool you just have true or false case. And this is going to be checking against whatever variable you pass in through here. And then it can also output a result. The gate is a little simpler in that, and it always assumes a bool case, and it stores that bool internally, and then you're just controlling it through the inputs and outputs. So kind of give you an idea what the gate's doing, and then the compare int is a single input, like we were talking about, and then multiple outputs. So these kind of are the 2 different scenarios of how the inputs and outputs are handled. So now let's go take a look at the script file. So here you have the gate. Again, you'll see that it just derives from sequence action, as we were talking earlier, you're pretty much always going to be doing. Notice that this does have CPP text, which means that it has multiple functions that are defined or editable in C++. You'll see here that this one actually does have functionality that's written here, but it's still encapsulated in that C++ text, which means it will be mirrored in the C++ code. So there might be something in this that has to take place there. And then if you look down here a little bit further, you've got the internal variables, and here is your open variable that we were looking at there. And it also has this auto comment thing. This is what was driving the comment above it, the object that actually told you whether it was open or closed. That's sort of just like an extra workflow improvement that didn't actually used to be present in some of the older versions of Unreal. And then you've got the auto close count, which is another internal variable, which I didn't talk about, doesn't really matter right now. And then the current close count. So if you look down here at the default properties, you've got the object name, just like we were talking about, the category, makes sense. You've got the default state of those three variables, defaults to open, and this is a comment, suppress auto comment, it's across all actions. And then you've got, right here is what we're actually looking for. So you've got these input links, and you'll notice the numerical values here, which is similar to, we talked about arrays, how arrays are zero-based. And that's essentially what you have here. You have a input links as an array, and if you hover over here, the IntelliSense kind of pops that up. So it's an array with a dynamic array that can have multiple elements to it. And so what you're doing here in the default properties is basically saying, I want to have 4 elements. You're numbering those elements, and you're also giving it a link description. So these are the 4 inputs that we saw. And then you've got the variable links here. You'll notice that this is set to empty. By default, you're going to have a variable output, variable link, I believe, that comes from just your sequence action class here. And in this case, for the gate, it doesn't need to have that. So you're basically wiping out that array, saying, I don't have any variables, I don't have any need for them because I'm tracking my own internal bools. So just clear that out so that you don't have an extra node on the Kismet block. And you notice it doesn't specify anything about the output links, and that's because by default you have a single output link that's already been labeled as out. And in this case, they don't need the gate to do anything else in that, so all they've added is the internal. We'll bounce over to the compare int and just kind of contrast that. Same deal. This actually does derive from a sequence condition. There's a difference, but kind of the same idea with the action, that there's a single base class that they'll all derive from. And you've got the same idea here with this activated function, which is handled in C++. And then you've got these 2 values here, which are the internal variables. And if we bounce back over, you'll see that really quickly. These are representing these 2 values, these 2 nodes here, A and B. And so here you've got the variable links, whereas the previous class set that to empty. It's actually defining, 2 elements and setting the expected type to an integer, which is represented by that teal color, and then also giving it a label A and B, and then also assigning the value of it, which is these internal variables, value A and value B. And then you've got the single input link, and then you've got multiple output links. So in this case, it does specify the output links because it needs multiple of them. So we've got these input links and these output links. So how do those work? So what you have basically is this idea of an output link, because this is an object, this is a sequence operation inside that base class, and it has this variable, has impulse. Kismet is sort of running, at some refresh rate. I'm not exactly sure what the refresh rate is, but presumably one tick per, or once per tick or once per frame, you're going to get an evaluation of Kismet. And so it's going to be looking over all of the Kismet actions and looking for output links or input links that have this impulse set to true. And it will actually do its operations, or its code or script from based on that, and handle, when the timing and what it's connected to, and activating. In this case, you're saying this output link has an impulse. So the actual Unreal side of the Kismet is going to handle firing that link, detecting what it's linked up to, what input it's linked up to, and then setting that input link has impulse to true. So that way, whatever code you might have that's waiting for an activated on a particular input link will then, fire either in that same frame or the next frame. So anyway, all you're really doing, it's kind of a confusing explanation, but basically what you're doing is you're not actually saying, I want to fire this output, or calling a function to fire the output. You're setting the value of has impulse to true and letting the Kismet system itself kind of manage when that is fired based on performance, and has so many milliseconds of the frame that it's allowed to operate. So sometimes it will actually happen the next frame of execution. But right here you've got the activated, you've got some simple comparisons. In this case, since it only had the single input, they don't have to even check for which input link was activated. They just say, okay, I was activated. I've got these 2 internal variables. What's the status of that? A simple logic check on that. And if this tests true, then fire my output link 0, because if you look down here, that's the condition. Output link 0 was A is less than or equal to B. That's what we're checking for right here. So you fire this true, skip over, or finish the execution there, because these are not else ifs. And so you're only going to fire a single output, and that's it. So that's kind of how the comparison works. And if we bounce back over to the gate, you'll see kind of similar thing, except in this case, they're doing on the activated function here, they're checking, instead of checking for logic of internal variables, they're actually looking at the input links, because the gate has multiple input links and one single output. And so it's just checking that bool value, saying, does this input link have an impulse? Is this set to true? If so, then I need to do some logic or some scripting based on that. In this case, it's setting the open to true, because input link sub 1 is the open. So the only job of this input link is to set this bool value to true, which it's doing. You notice here it does do a little bit extra logic for the auto close count, because we didn't really talk about it, but the gate has another variable internally that you can track the number of times that it's been activated, and it will auto close itself after so many times, but that's not really relevant to this. You notice input link 1 is the one that kind of starts with here in the logical flow, and goes 2 and 3, because those all have a particular thing that they're doing basically to the open variable. And then down here at the bottom is actually the input link 0. And kind of the reason for that, I assume, is the logical flow, is that this is doing an extra check, which is checking the value of this variable. And it wants to make sure and process if it was hit with multiple inputs, which is possible. You can have multiple inputs or outputs have an impulse in the same tick of execution. So one Kismet action could be linked up to both of those. And the order does matter internally. I mean, it's all tracked internally, so you don't have to worry about it. But anyway, basically it's saying make sure and do any operations on any of the input links that would have operated on the bool before I actually do the operation to say, hey, my actual input was fired. Should I allow pass-through or not based on this variable? So we're not digging into gate. I'm talking a little bit about the logic, but it just kind of, I think, helps reinforce how the input links are working, and kind of some of the things you have to take into consideration if you're going to be writing your own sequence actions or comparisons, is that things like multiple inputs can have an impulse in at the same time, and there is going to be an order to them. So things to think about when you're writing your own. Okay, so we've started up, Unreal here after compiling our custom one, so we can see that. We'll drop this in. So again, we have the default state, so we have a single input, a single output, and this default target variable. So if we wanted to do something specific with this, we can do that, by adding additional input links. So here we could have an input link, and we'll just leave the default sub-0, 1 description. I'm going to copy that, change its value to 1. So if we save that, and then quickly compile and reload the editor. Okay, so we'll open up Kismet now that we're back in the editor, and look for our action. Drop it in there. Not a big change, but there you see we've got 2 inputs, and the custom label on that was my custom input. So it's really now we're going to go into it. You can look at other examples of sequence actions, conditions, and events for kind of how you do more of the functionality internally. But that's a quick overview of kind of how the inputs and outputs links work, and as well as the variables. It's really all you need to know kind of as far as foundation of how Kismet works and how those are set up, and then the logic that you derive or contain inside of the activated function there is up to you. As well as you can look at some of the other actions that do some heavier lifting, we'll say, and you'll see that they do some other things, internally maybe, or some other functions, but kind of gives you the overview. All right, so that's a bit about the Kismet extensions you can do or modifications in UnrealScript. And so now we're going to look at a more, another custom class that we'll create, but I wanted to show you how you can actually take those classes and see them here when you're in the editor in the actor class browser. So you'll see that you can add your own classes, and they'll show up here based off of how you're driving them. The tree here kind of represents the hierarchy of inheritance. So fluid, surface, actor, movable, is an extension of fluid surface actor. And so we're going to go ahead and do an example of that and set up sort of a cheesy, what I'm calling a compound mesh. Not super practical maybe for games, depending on your purpose, but basically we're going to create a single mesh object class that will actually have two mesh components, so it can have two separate renderable instances, but it's all treated as one object in the editor and in the game. Okay, so here's our compound static mesh actor class we were talking about. To add this, I just did a right click here on classes, added a new item, created the name compound static mesh actor, and then hit OK. And by default, it was deriving from object, and so I updated that. Also made it, added this keyword, class keyword placeable, and this is what will make it an object class that will show up in the actor class browser in bold. You'll notice there's some that are bold and some that are not. The idea or the convention there is that the bold ones have that placeable keyword and are objects that you can place in the editor and save into a level file, whereas the other ones are not there, just there as a base class essentially. So a couple of things I added to this simple class, just to show you an example of what you can do by extending something that already exists in UnrealScript as a totally usable object. A static mesh actor is one of the most commonly used actors or object types in the editor. I mean, every level is built out with thousands of static meshes. BSP is used, a lot as a foundation, but then everything kind of gets set dressed with the static mesh actor. So what I did here was just extend from that and then add a single variable. And you see the variable also added the parentheses here with a name, which is static mesh actor, which is already going to be an object category. We'll open up the editor here and show you kind of why I did that. But had I left this blank, it would have created a new category, which was the default name of the class, which would have been okay, but then we would have had the two static mesh components and two separate areas of the properties, which is not very intuitive or useful. So also added a constant here because we don't want this to the actual static mesh component to be editable. The static mesh component has its own internal variables, which we'll show you here on the UI for the properties, which has a mesh component variable, which is what we'll be setting. But you don't want to be able to actually edit the static mesh component object or variable itself. So that's why it's got the const and the editor const. And just gave it the variable name here. Inside the default properties, you're going to see the begin end object for the component. The static mesh actor, if you look at this class, we can right click, say go to definition. This inherits from or extends the static mesh base. And if you look down here, it's doing the same thing and creating static mesh component 0. So by extending this class, just made a static mesh component 1, and then go ahead and add that component. So that's really all this is. I mean, it's very, very simple. But now we can open up the editor and show you a static mesh, side by side with a compound static mesh, and kind of what the difference is, so you see the correlation. Okay, so here we're back in the editor. Click on the Actor Classes tab in the generic browser. So here, again, you've got the list of all of the different classes. You see Actor up here is kind of like the topmost. That's all that's visible here. And these are all the classes that are derived from Actor, and some have multiple chains of inheritance here. So what we're looking for is the static mesh. Okay, so under static mesh actor base, you've got static mesh actor, which is a placeable object, and as you can tell by the bold, and that's kind of the typical one. And then you'll also see it has some derived classes or child classes. There's a total of 4 of them, but the one we're interested in is the one that we just created, which is the compound static mesh actor. So you'll see that entry there. So just to compare what kind of the difference is, I mean, we've looked at it in the script, but I'll go ahead and drop in an instance of the regular static mesh actor. So we'll jump over to the content browser, go ahead and select this create mesh. I'm going to make sure I have static mesh selected. I do. I'm going to right click, add actor. Need to load the mesh into memory first. And so now I get this option to place the static mesh. All right, so there we go. All right, so there's our just kind of typical static mesh box. So now if we open up the content browser again, and we'll leave the static mesh selected that we have, But this time we're going to select the compound static mesh actor. And we're going to place one of those guys right here. So a few things that are going to be different here. One, when we place it, it doesn't actually come in with that mesh already assigned to it. There's additional script that would have to be added to get that sort of contextual stuff happening. Since the class is very bare bones and simple, the only difference right now is that it has that extra mesh component, which we can tell by opening up the properties. So what I'm going to do is open up the properties for our compound static mesh actor, and I'm going to lock it. And then I'm going to change my selection here to over here and open up the properties for this guy. So here we have the regular static mesh, and you'll see under the static mesh actor category section of the property panel, you've got the local variables that we saw inside of the static mesh actor class, namely the static mesh component. Now remember, the component was marked as an editor constant, which means that even though I can see and expand this, I can't delete this component, right? So if it was not a constant, that would have the option to remove that. So we want to make sure that this is constant, and then the stuff that is editable is what is contained inside of that component class, which what we're interested in is the actual static mesh component, and there's a static mesh. Now you see it already is populated because when we added it, it populated that variable for us based off of the context of what was selected. There's our crate, and that's what we're looking at right here. So then we look at our compound static mesh though, and under the same heading, because we in the script file here took the time to go ahead and label what category of the properties we want it to be under. Otherwise, by default, it would have chosen the class name if you don't specify anything there. So we've made sure it showed up under the same, and you'll see the normal static mesh component that's coming from the static mesh actor class. But because we're a compound static mesh, you now see this additional component that we added, and this is secondary. So what we can do with this, we still have the crate selected in the content browser. We can come into the first static mesh component, and we can go ahead and green arrow here to use selected object, and there you go. So I'm going to go ahead and close the static mesh actor properties. So now our compound static mesh looks, exactly the same because they are the same. We're just right now we haven't changed or altered anything that wasn't already part of the static mesh class. So now if we bounce back over to the content browser and we select this mesh sphere and we close, and now we're going to add this as a secondary mesh just to show what happens. So now I add the selection. Okay. So now I have two mesh components, which are both now populated with an actual mesh reference. So you see that I have a single, selectable object. Notice that the only object with collision is the first object, and that is because if we look at the script file here, when you look at static mesh actor, notice that it is setting its collision component to essentially the collision component of the static mesh component. And then it also sets the static mesh component to that, and then adds the component. Here, we are not taking the step to actually do the collision. And that's kind of intentional because there's some restrictions unless you're doing special objects that a single mesh can only have, or a single actor can only have one collision object stored on it. So it would be weird and probably cause some problems if you tried to add the collision component for the secondary one. In this case, it's those two meshes that we're using to visualize it work well for visualizing that there's two, very different meshes that are being rendered by the same actor. But this, would not be the typical use. But what you might do is have something like a weapon, or not even a weapon, but like a static piece of geometry that could have interchangeable pieces on the top, and so. In a lot of cases, people will prefab those or just make two separate versions of it. But if you wanted to say, if you were really trying to save memory and cut down on geometry, you could have the base of some object be truly shared or instance, and then you could have different versions kind of stacked on top of it and have those not have collision based on the size, or the base could include the collision for it. Just a lot of different ways you could do it. The compound idea of a mesh is not implemented by default in Unreal for good reason, because there's other complications with it, but it kind of is a good example of how you can simply extend an existing class. And in this case, in just a few lines of script, you've got something totally new, new placeable object, two renderable instances in it, yeah, so that's kind of it. And the other thing I liked about this example is that it just reinforced what you can do as far as placing your own custom, properties in here. So if you had not put, just to kind of review the variables, if we had left off the parentheses completely, this static mesh component would not even show up. And since we're not setting a default anywhere, essentially it would be useless because you couldn't actually change what was being set to it. But by making it editable in the editor with the parentheses, as well as specifying which category or group of properties, which in this case is static mesh actor, you have a very readable property menu here that is kind of intuitive as far as what's here and what's stored here. And you'll see, there's the other kind of constants that are coming from these property panels or sections are coming from the actor base class. But you can, update these. So if you had a particular object that you wanted to add some special, properties to that fit under these categories, you can certainly add to them just like we did for the static mesh actor. All right, so that's kind of an overview of classes, how you get them to show up and be placeable here in the actor class. Well, just getting them to show up just means you have to at some point derive from actor, but the placeable versus non-placeable is important to remember, and then also how to make sure that the properties are going to be edited and editable and easy to find and intuitively placed. All right. So now let's take some of the things that we've learned, specifically classes and extending your classes, and let's go ahead and do a practical example of how you might do something with the class extension. And let's go ahead and set up our own custom weapon. This is really simple to do. What we're going to do for this example case is just base something off of the existing rocket launcher. But what we can do is take we'll just sort of merge two weapons together, and we'll take the particle effects from the shock rifle and the weapon itself from the rocket launcher, and we'll kind of merge those together, and then we'll change the dynamics or the processing of the actual projectile to bounce off of the walls. So basically we'll get a ricochet rocket out of it. Pretty small amount of script required to do an example like this, which is a really good case and example for why class extension is so powerful. So let's go ahead and set that up right now. So the first thing we're going to do is go ahead and add a couple of new classes to our project here. One of them is going to be the weapon itself, which we're going to extend off of the rocket launcher, and then the other is going to be a new projectile class, which will be our custom rocket that will look more like the shock rifle particle effect. So what I'm going to do is right-click on the classes folder here under our custom project and add a new item. There is this UT3 weapon template which will automatically stub in an INI file for you with some tunable values as well as a localization file. For this example though, I'm just going to use a regular UnrealScript class. But I am going to follow the naming convention of the weapons, and so what we're going to do is call this UT_wep_, and we're going to call this plasma rocket launcher. Alright, and then we'll go ahead and add that file. So you can see we have our new file over here in the solution, and it's set it up to by default to extend off of the object class, which is kind of the default for that template. So what we're going to go ahead and do is update this now to extend off of UT_wep rocket launcher, and you'll see the IntelliSense here is already helping us out. And what we're going to do is we're going to extend off of the rocket launcher content, and we'll open this up really quick. Right-click anywhere in this class and go to definition. One of the great things about the infringe is the way you can jump around. And in addition to the IntelliSense, is the kind of the typical Visual Studio functions like that are supported. So the UT_wep rocket launcher content class is basically it's just the default settings for what people or what you'll see as the rocket launcher in the game. The rocket launcher itself is it's standalone class, and the content just kind of is a simple extension of that class that allows them to set all of the default parameters for it. So by us extending off of rocket launcher content instead of the rocket launcher itself, we don't have to go through and set all of this stuff up, to mirror the behavior of the rocket launcher. As you can see, there's a lot of variables here that are being set. Some of them also are, obviously tuned to some pretty specific values here that
it would be a lot of copy and paste or a lot of trial and error, so it's just not really necessary and not really getting the benefit out of the class extension. Because all we really want to do in this case is we want to override a few things like what ammo it uses and things like particle effects and things of that nature, maybe speed. So we can kind of selectively choose what properties we want to override without having to override everything by extending this, which basically just gives us all these default settings automatically. So bounce back over to our new class here and drag this over in front. So we've already got our extension of the way we want it. And so for the actual rocket launcher, all we really need to do is tell it to use a different projectile class. So what we're going to do is we're going to override the weapon projectiles. And we're going to set this equal to the class. And I'm going to go ahead and type this in. This is going to be the class that we're going to create here. So I'm just getting a little ahead of us here for the example. So we're going to make a plasma rocket class. And I know that the current rocket launcher, I believe it defaults its weapon or its ammo count to 8 or 9. Yeah, 9. So for our example, let's go ahead and bump that up. So ammo count. We're just going to set that. We'll just double it. Go 18. Okay. Now that we've got our simple rocket launcher class, right now it's a fully functioning, class in itself. It's not really changing anything from the rocket launcher, the base rocket launcher in the UDK or Unreal Tournament as the weapons featured in. But we have told it to use a different projectile class, so now we need to go create that class. And if you ever are setting up your new class, like in this case you want to extend something to weapons, you can just look in the UT game folder and then classes, and there's a lot in here, but you can find kind of what the convention is. So in this case I'm kind of going off of, you see there are some UT weapon classes, but those are more things like the lockers and the actual pickup factory. The weapons themselves, they've gone with the UT web convention, so that's what I was following when we created this class name right here. So let's go ahead and scroll back up to our classes section, and let's go ahead and add another new item. And this one, following the convention that we just were looking at down there, we're going to call this UT proj for projectile, and we'll call this plasma rocket, which is what we told the new rocket launcher, plasma rocket launcher class we were going to be looking for. So that's what we're giving it right here. Alright, so we got this new class here. Now this one we want to also extend off of we want to change as few things as possible. So what we're going to do is just go ahead and extend it off of the default rocket class right here. So UT proj rocket. So here's where the majority of the changes we're going to make are going to be. But what I want to do really quickly is go ahead and actually take a moment here and run the game to show you what we've done. Because right now, since we've extended this, and even though we told our new rocket launcher essentially class to use a new type of ammo, because we've done the ammo here, but we haven't changed anything since extending off of rocket, I'm just going to jump into game real quick and show you that this new plasma rocket launcher will be available in the game, but it will behave just like the rocket launcher you would expect to see. So I'm going to go ahead and build this, and then we'll jump into game. Okay, so now that we've built our scripts with the new files that we added for the weapon, we're going to go ahead and demonstrate it here in the editor. So we're going to go open up the foliage map. This is a map that comes with UDK 2010-11 November, and this is a really great looking map. Kind of shows off some of the power of the renderer, as well as a lot of the new visual kind of functionality and the speed tree and everything else like that. So it's a really cool map. What I've done is I've gone in here and updated the player start to be over on this side of the map. It was starting out through the structures there. So what I've done is add that player start, or move that player start, and then also added this object right here, which is just a UT weapon factory. So if you want to drop one of those in, if you open up the content browser, go to actor classes. If you have show categories checked, you're going to go down to Pickups, Weapon, UT Weapon Factory. And then with that selected, you can close that. Just right click and add Weapon Factory here. And you'll have what we placed here. And if you double click on this or select it and then hit F4 to open the properties, you're going to see the very top set of properties here is for the factory itself, and you're choosing the pickup class. And you can see that the plasma rocket launcher, which is the new class that we just created, is an entry in here now. So with that selected, I'm just going to go ahead and run the map really quickly. Okay, so here we are running in the level now. This is the foliage map, as I mentioned, and we're starting the new player start. So if I walk over this hill here and look here, you're going to see the factory, and you notice it is using the rocket launcher mesh, which is expected. So actually everything about this should behave just like the rocket launcher. So if we use the primary fire, we fire a rocket as expected, blows up on impact. So basically this is just a rocket launcher, right? But what's different is that this is actually our new class that is set up to allow us to modify it as we see fit. And then we'll see those changes, but we can reuse the same mesh in this case since the rocket launcher looks good. So okay, so let's bounce back over to Visual Studio and let's start making some changes to the projectile. And we're going to go ahead and set that up to bounce off of walls and also use a different particle effect to distinguish it. Okay, so now that we know that our new class is functional and usable in the editor and placeable on a map, and it's using our new projectile class, we know that basically, for the terms of the rocket launcher itself, we're kind of done with that because the remainder of the changes that we want to make are to the projectile. So for now, I'm going to go ahead and switch back over to the plasma rocket class, which we haven't changed it at all. Right now, it's just behaving as you would expect, just like it is just a rocket. So I'm going to go ahead and right click and go to definition so that we can look at some of the stuff that's in here that we're going to want to override. So one thing that we know for sure that we want to do is change the look of the particles. So I'm going to go ahead and grab these two, the projectile flight template and the explosion template. Just copy those lines and take them over to let's go ahead and move this over here and close this file. Okay, so in the default properties of our projectile class, I'm going to go ahead and paste those in. And I think a couple other things that we would like to change here is the light class that they use. This is going to be as the projectile travels through the air, it emits an actual light from it, creates a light source. So we're going to override that. We won't worry about the explosion, although you definitely could if you wanted to. But for this case, I think we'll just do there. All right, so what we're going to do is go ahead and change the class here to be what they use for the shock rifle combo. So we want the UT, this is still from UT game, and we want shock. All right, so this is going to be the class that they use for the shock ball, which with the shock rifle can be used to do the shock combos. Okay, so that gives us our light source that we want, or our color that will match the particle that we're going to do. So to do the particles, you can type in here manually if you know the name, but you also have to know the package that it's coming from. So you need the full qualified path to that particle effect. So one of the handy options that exist in the editor is you can copy the name of any object in the content browser to the clipboard, and it will copy exactly formatted this string. So let's go ahead and open up or bounce back over to the editor. Okay, so here in the editor, you can filter by the different object types or different tags. So we'll go ahead and filter by particle systems because that's what we're interested in right now. And under UDK game, we're going to find the weapons category. And you can see right now we're filtering by all weapons, so we can take this down one further level and go down to the shock rifles, since those are the ones we're interested in. So for our actual projectile, what we want to use is the shock rifle ball, which is this one right here. And so I'm going to right click on this, and you can see this
option in the context menu, which is copy full name to clipboard. We're going to go ahead and select that, and then bounce back over to Visual Studio. So for our flight template, we're going to highlight this and paste over that. So the name that was copied to the clipboard was the full qualified name in terms of how Unreal structures the packages to the particle effect that we want, which is this right here. So this will now be the particle effect that will be used for the projectile itself. The next thing we need is the explosion. So again, we'll jump back over to the editor. And for this, we'll use the shock rifle ball impact. Same thing, copy name to clipboard. Okay. So just a couple of quick changes, but we already have what we need to give the visual variance for our new projectile. Another thing that we want to do is jump back over to the original rocket class, and let's go ahead and grab the explosion sound. Again, you can kind of pick and choose what of these you would want to override. You know, obviously you're going to be going through some consistency, but in this case, I think that we can get away with just picking a few of them. So what we're going to do is grab sound cues, go sounds, weapons. Okay, so here we have the shock rifle, and the one we're looking at is the combo explosion cube right here. So again, same thing, copy full name to clipboard, jump back over. All right, so now we have our particle effect to be used during the travel, the flight time, the explosion, new light class to make sure that we're emitting the right tone of light, the right hue for the particle effect we're using, and we have a unique explosion sound. Okay, so let's go ahead and save this and build. And did this on accident, but it's a good thing to show, is you'll notice that I'm going to get an error, which is telling me that the game is still running, so you have to shut down the editor before you can build scripts. So we'll go ahead and close down the editor and build. Okay, we're done building, so let's go ahead and fire up the editor again. Go ahead and load up the foliage map that we used. Alright, here we go. And so you can see we still have our content factory right here, weapon factory. So we're just going to go ahead and run the map. And hopefully, if we've done everything correctly, we will see the changes in our new projectile. Alright, so let's walk over to our pickup here. Everything looks the same. And now when we fire, we should see the different projectile. Alright, perfect. So we've got the shock ball as expected. You notice see a rather large sound effect for the explosion that would normally be used in conjunction with the shock ball. Alright, so everything else looking good, behaving just like the rocket launcher would. We have our new visuals for the particle effect. So there's a couple of things we want to change, including obviously bouncing off the walls, because we want to have this to be a ricochet style weapon. And there's also a few things we'll want to tweak. You'll notice that it's traveling at the same speed of rocket would, which is a little fast. Considering what we're going to be doing with the bouncing off the walls and stuff, a slower speed is a little bit better, both for visually and kind of from a gameplay standpoint. So we can switch that up in our new extended class. So let's bounce back over to Visual Studio. Alright, so if we jump back over to the rocket class, which we extended from, we'll notice that with the exception of the post begin play function that's been overridden here, it's just a setting of the default properties. So in order to see what functionality exists in the projectile, and in our case the functions that we want to override, we need to look at projectile class. So with Visual Studio, if this is the first time using it, there's a few things that are good to know. Based on the context of what you're looking at, or kind of where the cursor is on the page, you have the class view here, and then you have the function and member variable view. So this is really helpful for kind of getting a snapshot glance at what what functions are available inside of the class. So the ones that we're looking for in particular are the process touch. Let's find out if that is here. So it is. So if we click on that, it'll jump us to the function right here. Okay, so this is one of the functions that is going to be called whenever your projectile comes in contact with anything. So in this case, it's looking to this internal member variable, provided it's greater than 0, it's going to call the explode function, which is essentially going to destroy your projectile, and also the explode function will do any things such as apply damage within a radius, depending on the other variables. And then the other thing here is that's going to be the radius damage. If in this case, it's also looking at the object that it came into contact with, which is passed in as other, and it's going to just apply damage to that a fixed value because it actually hit it. So in the case of what we're going to be doing, we're wanting it to ricochet, and so all we really care about is the direct damage, but we don't want it to detonate on contact. So if we copy this function and jump back over to our plasma rocket, and I'm just going to paste this in. Go ahead and format this up a bit. Okay, so really all that we really want to do, like I said, is just apply the damage. So what I'm going to do is I'm going to remove the else case and remove the damage applying. So we're going to basically convert the if case into other, which is the object passed in that we came into contact, is not equal to instigator. Okay, so basically we're saying as long as the object it came into collision with is not ourselves, then go ahead and apply the damage. But this way it won't hurt us. So there we have overridden the process touch function, which was already inherited through the extension of the rocket class, which was extended from the projectile class. So we just went and grabbed the process touch function, overrode it here locally, so now we get our own unique behavior. One thing when you're overriding functions, you have the option to call what is called the super. There's a keyword. So you can also call like super process touch and pass in the appropriate, basically you would just pass along the same parameters in general. And what that will do is if you're overriding the function, but you're basically kind of appending your own, or prepending or appending your own functionality or your own particular logic, then you can still call on the parent function if you don't want to rewrite all of the logic and have to do a bunch of work. Just copy and pasting. So for instance, if I was going to leave all of the code as it was when I pasted the function in, but just add one new line of logic or a couple of new lines, one option is to actually only add the new lines, remove everything else, and then just call the super where it's appropriate to do that functionality. But in this case, we are not wanting to do that because we overrode this intentionally so that the normal behavior of the projectile class version of this function, process touch, will not happen. So now what should happen if we were to run this would be that this basically would do nothing whenever it came into contact with the wall. So the next thing we're going to need to do is set it up to handle the bounce. Now there's another function that we want to override called hitWall. And so if we jump back to this here, and we're in the projectile class, if we look here and notice that hitWall does not show up, that's because hitWall is not specific to a projectile. So if we go back up to the top here, the UT projectile, and then we can kind of just trace it back up. Instead of going right to it, you could also do a find in files, but I'm just going to kind of trace back up the hierarchy of the extended classes here so that we can get an idea kind of what's happening. So you'll see here, still nothing. So then there's a base projectile class instead of the kind of project-specific UT and UDK ones. So now we're in the projectile class. This is a very large class, so it's taking a little bit of time here to load up. A lot of times when you get to the kind of the utmost base class of a particular object type, the classes will be rather large because there's a lot of functionality that they're supporting. So here we go. So notice that there is the hitWall function. Now this function is normally doing some heavier lifting stuff, like it's handling if there's dynamic objects that'll apply, make dynamic, so if you hit a physics object that's been basically in its sleep state or its default state, you can wake objects up and do that kind of stuff. We're going to grab this function, but we're not going to, or similar to what we did with the process touch, we're going to kind of remove and kind of override it to do specifically what we want it to do. So let's go ahead and grab this. We're going to jump all the way back over to our plasma rocket. Paste this in. Okay, so the singular we're no longer doing. Don't need that, and so because we're overriding this. So now we have the hit wall. We're going to leave all the parameters, of course, the same. We can get rid of this local variables. We also are not going to call the super because we do not want this to perform any of the previous actions. Basically, we're going to get rid of just about everything here and just write our own stuff. So what we want to do is we just basically want to change our direction. So if we take, I'm going to create or set our velocity, apologies, equal to, there's a function called, it does not show up in the IntelliSense, but mirror vector by normal. And in that we are going to pass velocity. And we also need to pass in to this the hit normal, which you'll see was passed into this function, hit wall. So this is the vector that represents the vector of angle, or the angle that the projectile collided with the wall at. All right, so now we're going to have our velocity, which is going to become the mirrored vector of the hit normal. So we'll go ahead and add our semicolon at the end there. And then the other thing we're going to do is set rotation. And there's a function we're going to call rotator. We're going to pass it our new velocity, which has been updated. Okay, so all right, so now we have our new velocity. We got the new velocity based off of the mirror vector by normal function, and then we use the set rotation function to apply that to our projectile. So the next thing we want to do is go ahead and change some more default properties. So we've got in theory, we've got it all set up now to collide with the wall and bounce off the wall by mirroring the vector, and then updating the new rotation based off that velocity, which we catch here. And then we've also overridden the process touch to no longer call the explode function on the projectile when it comes into collision with anything. And in this case, we're basically saying as long as whatever it has collided with is not us, then go ahead and just apply damage to it, or tell that object to take damage. So a few other things, as I mentioned earlier when we were looking at it in the map, the projectile moves right now at the speed that the default rocket launcher does, which is fine, but given the context of what we're doing, I think it's a little bit better to slow it down. So I'm just going to set the speed variable to 400. Now, whenever you're coming in to override variables, one thing you may want to do is obviously give yourself some context of what kind of the value range is. In this case, since we're deriving directly from the projectile rocket class, and this class is primarily a setting of all the default parameters, it's pretty easy to kind of trace back and find out what things we want to override. So you can see right here, the rocket launcher speed was substantially higher at 1350, and then we're setting ours to 400. And the other thing that I'm going to change is, you'll notice there is a draw scale variable. Actually, in this case, it doesn't use a draw scale. It's because the projectile is fine the way it is. But projectile class, further up the hierarchy, does have a draw scale variable. In fact, that comes all the way from the base object class. So what we're going to do is set this, and we're just going to scale up the particle just a bit. Not too much, just 1.2, 120%. Not super critical, but kind of makes it a little bit easier to spot, especially as it's bouncing around. All right, just quick recap. We've extended rocket to create our plasma rocket, overridden the process touch function to no longer essentially detonate the projectile on the first contact or collision that it makes. We've also told it when it comes into contact with an object, the hit wall function, which is what determines the normal and the object it hit, we're basically just grabbing, all we really care about in this case is the hit normal. But we do need these parameters around to match the definition of the function in the parent classes. So we mirror the vector and set that into velocity, and then we apply that velocity to our projectile. Alright, so let's go ahead and save this. And we're going to build. Now I've already shut down the editor in the background. Just remember, if you're ever going to build, you need to close that down first, otherwise you will get an error. Okay, now that our build is completed, we'll go ahead and relaunch the editor. Okay, we'll go ahead and jump back into the foliage map, which is the one we've been working in. Alright, here we go. So we don't really need to change anything with this factory. We're still just trying to spawn the new plasma rocket launcher. So we can actually just jump right into the play and editor option. And look around. So there's our rocket launcher. Alright, so last time we had this and we kind of, noted as basically it was just behaving like the rocket launcher would, but we had the new projectile. So now, if we've done everything correctly, we should see this bounce off the stone path here when I shoot it. Alright, and you notice that it's moving substantially slower because we dropped that speed down to 400. Alright, so the cool thing about this is not only is this map really great looking, but it also has a lot of interesting kind of pinball machine shapes, which is perfect for what we're doing with a ricochet type weapon. And you may find that this is too slow, and you'd want to actually speed it up a little bit, but kind of adds to the sense of dread if you can see this thing bouncing around and kind of coming. It's also fun to watch it fly around the map. So in this case, another thing you'll notice is that we increase the draw scale to kind of make the projectile a little bit more readable, stand out. But you will see that it clips through things because of that. The collision that it's currently using. So you could go update the collision, because right now it's using whatever the collision is from the classes it's derived from. Or another option would be if you're not, feeling like right there you can see that it did collide, but it also clipped a lot. So if you're not feeling that it really needs to be that big, then you could also just go in and modify that draw scale variable and even reduce it down below the 1.2, below 1 even, and take it down to smaller. There's other things you can do too. You'll notice that right now we are not doing any filtering based off of the type of object it collides with. So, you would expect it to collide with stone, but maybe you wouldn't expect it to collide with the foliage on the trees. But as you can see, it is. So, you can get in there and filter out certain things, but for our case and just kind of showing how you can extend a class of a weapon, create your own weapon, and do some unique things with it. Okay, so back here in the editor. So basically I'm just going to recap really quickly what we've kind of covered here. It's not too complicated, but it does touch a lot of different areas as far as the class extension, function overriding, and then also, even placing the object in the map if you're not used to the editor, haven't placed a lot of objects or opened up maps before, then just want to make sure that kind of have a good grasp on everything that we've done. So this is the foliage map that comes with UDK November 2010. We adjusted our player start here, although that would not be required, and then we placed the weapon pickup factory, which you can get to by going to the content browser and then going to the actor classes tab, and then with the show categories filter on, then you're going to go to pickups, weapon, and UT weapon pickup factory. That's the object that we placed right here. And then we open up the properties, which you can get to by double clicking on the object itself or hit F4 with the object selected and highlighted. And our new class that we had created, our new weapon, was the UT Web Plasma Rocket Launcher. It shows up in the list, and that's what we selected, and that's what was spawning in that we were picking up. Back over in Visual Studio, can see that we had our new Plasma Rocket class here. All of the other tabs that are open here were just the
pretty much the hierarchy of the class extension. We kind of traced our way back. So plasma rocket, derived from rocket, rocket derived, or extended projectile, projectile, extended UDK projectile, and then we went all the way back to the default projectile class, which if we go to the top, you'll see that it actually just extends actor. So this is kind of where our true projectile starts as far as variables like speed, which we overrode. There's also a max speed and just going to be a lot of internal variables. The damage, that's another one that we could easily tweak to be different than the rocket launcher, especially given the fact that these can ricochet around. There's different ways you can handle it. Here's where you get to start being kind of, creative in designing how you want, in this case, the weapon to behave, because, for instance, the damage value on a rocket launcher, everybody expects it to be a high damage, high impact weapon. And so what we've basically made is a bouncing rocket, but there's different ways you can handle it. Once you get in and start overriding the collision, you have the option to say, I want it to collide with walls and static geometry and even havoc, rigid body actors, the K actors. But you may not want it to actually collide with pawns. You may want this to apply damage to them, but keep traveling. Basically, it could be an instant hit kill. I mean, that would be super overpowered, but basically, if you're going to have something that could hit multiple people, like it could pass through 3 people in a row or something like that, then you may want to turn the damage back to sort of kind of keep a balance, because it's obviously a very powerful weapon. But basically, since you're in control of the collision, you're going to be the one in here. You can mess with how it handles when it processes a touch event. So you can add logic in here to filter by class type or by object type, essentially, and do that kind of stuff to where it behaves differently if it hits an actor or a pawn than if it hits a static wall. We've got the hit wall, what happens when it does make that collision. In our case, we're just bouncing right off of it, but you can do other things like you could place actually, it probably would make more sense in the process touch. You could do decals here if you wanted to leave scorch marks on the static geometry. You could have decals, all kinds of good stuff that you can do. And in this case, it's just these 2 simple functions. This gives you what happens, physically to the projectile, and this is what happens sort of just in general. It's more generic, I guess you could say, since it's any touch event, which is any collision, be it something that would cause it to bounce and also something that would just pass through. Like, for instance, process touch goes as low as like the volumes, the trigger volumes and stuff that gets called if anything intersects the BSB planes that those trigger volumes create. There's no collision there, but it still is processing that stuff under the hood. And then, this is our biggest example of default properties, but if you look at other example classes or classes that we're extending from, this is a really, good way to see what variables are kind of in use here. It could be a bit overwhelming if you go all the way to the top, or I guess you said the lowest level base class. Say for projectile, there's a lot of stuff in here, although because it's commented, actually this class isn't too bad, but some of the classes can get really big and a little overwhelming as far as trying to figure out what all the variables do. So sometimes it's a good idea to take a look at one of the derived children classes and just kind of see what they're using and how they're using it. You get an idea of the range of values. For instance, momentum transfer. You're not going to have a very good idea what that number means, like what a 1,000 means compared to, in this case, 85,000. But if you've played the game, Unreal Tournament, you have an idea what the rocket launcher is like and that, kind of rocket jump momentum transfer. So you can get an idea of the range and then make it a lot larger, a lot smaller, half it, whatever you want to do. Some things are pretty self-explanatory, like damage radius, damage, speed, those kinds of things. But just a good idea to get in and get comfortable with kind of where stuff is stored. And then you get some creative ideas for once you see something, you may not think too much about it, but you may see a variable that kind of triggers something in your head, like, oh, I'd like to do something with that. I have an idea for how I could manipulate that particular thing in my new weapon or my new object of some sort. And it doesn't always require you to write a lot of new supporting functionality. In the case of these variables, the functionality is more or less already there, depending on if you need to flex it or even change the way it works. But if what it does sort of out of the box, I guess you could say, is what you need it to do, but you can use it in interesting ways, then there you go. That's the power of UnrealScript. All right, so I'm going to open up the other projectile class. I'm sorry, the weapon class. Just real quick so we can see the final two classes that we created. So we created the weapon, which extended the rocket launcher content, because content was the class where it kind of set up all of the default properties. And we wanted to have to change as little as possible. So what we were able to do was just come in, exchange the projectile class that we're using, which is the new class that we created here, and then we just doubled the ammo count. So very simple, very easy. And here's where we handled our visual difference as well as the kind of the design of the weapon, so to speak, with the speed and the draw scale. Okay, so that's kind of a good overview of how you would create your own weapon. Of course, if you have new assets that you want to use, or if you've modeled your own weapons, and there's ways that you can import all of that stuff in. There's other examples of that provided by Epic and other resources. E3D has other things that you can look at for importing your assets in to the Unreal environment. And once you have all that stuff, you could build your own weapon from scratch. You could have your own model, your own animations on it, your own particle effects, whatever you want to do. So, all right. Hope you've had fun and enjoyed this DVD and this look at UnrealScript as a kind of an intro to how to program in UnrealScript and what you can do with it. And hope you have fun playing around and learning new things.